Lokeshri ma'am.
Yes, ma'am. I'll start.
Lokeshri ma'am.
Yes, ma'am.
Can we start?
Yes, ma'am. Good morning, everyone. Good morning, all the participants, authors, session chair, and session coordinator. I would like to invite the session coordinator, Dr. P. Mirnalni, and also the session chairs, Dr. D. Venkatavara Prasad, sir, Professor, Dr. A. Chamundeshri, ma'am, Professor, Dr. K. Vallidevi, ma'am, Associate Professor, for the paper presentation. Over to the session coordinator, Dr. P. Mirnalni.
Thank you, Lokeshwari ma'am. Good morning to one and all present here. I am Dr. P. Mirnalini, working as Associate Professor in the Department of Computer Science and Engineering. We welcome all the delegates to the 5th edition of ICCIDS 2022. Congratulations to all authors. Your paper have been selected after several reviews. Before the presentation, a quick profile of the session chairs. Dr. D. Venkatavara Prasad. He is the professor in the Department of Computer Science and Engineering and has more than 20 years of teaching and research experience. He received his PhD on the work on chip area minimization using internet length optimization from the Jawaharlal Nehru Technological University, Anantapur. His research area includes computer architecture, GPU computing, and machine learning. He has published a number of research papers in international and national journals and conferences. The second chair, Dr. Chamundeshwari Armugam. She is the professor of Computer Science and Engineering Department at SSN College of Engineering. She received her PhD degree from Anna University, Chennai. Her research areas of interest includes software estimation, software testing, software project management, cyber security, cyber forensics, machine learning, deep learning, and psychology. I welcome you, ma'am. And the third chair, Dr. Vallidevi. She is working as an associate professor in the Department of Computer Science Engineering. She is with SSN since 2005. She received her PhD from Anna University for her thesis titled Pattern-Based Dynamic Reconfiguration for Service-Oriented Applications. Her research area includes cloud computing, big data analytics, machine learning, deep learning, image processing, software engineering, design patterns, software architecture, and service-oriented architectures. She has published around 20 research papers in international, national conferences and referred journals. I welcome you, Dr. Vallidevi.
Thank you, ma'am.
Thank you.
Mirnalini ma'am for introducing us.
Yes, ma'am. I want to give some instructions about this session. The time given for each presentation is 10 minutes and 5 minutes for discussion and question paper. I request every author to adhere to the timings. Can we start, ma'am? Sir, can we start?
Yes, ma'am, we can start.
Yes, madam, we can start.
Yes. Yes, that paper ID 12, a survey on cervical cancer detection and classification using deep learning. The authors are Hemalata and Vetri Selvi. I request the authors to take up the session.
Yeah, yes, ma'am. Shall I share the screen?
Yes, ma'am. Yes.
Okay, ma'am. Yeah, is my PPT visible?
Yes, yes.
Yes,
can you make it as a
full screen, ma'am?
Yes,
ma'am. Yes, ma'am. Good afternoon to everyone. My topic is on a survey on cervical cancer detection and classification using deep learning. So my name is K. Hemlata and a research scholar in the Department of Computer Science and Engineering in College of Engineering, Guindy, Anna University. So is my slide moving, ma'am?
Yes, ma'am. Yes.
Yes, ma'am. Okay. The agenda of this is introduction, literature survey, image classification techniques, models used, and analysis of the existing techniques and conclusions. Okay. So next, now introduction, I am going to explain about what is about the medical image processing or how important is and what the cervical cancer plays in this. So medical image processing has been a great significant in the field of medicine, and also here many medical image processing techniques have been introduced. So the main area is not covered is cervical cancer because it is unknown to many of them. So cervical cancer, this is the most common cancer about impacting 5,70,000 people globally. So this cancer is being affected by the human papilloma virus, which includes the cervical cancer causing the abnormal cell development in the cervical area. So again, we are going to see deep inside this about how computer techniques have been emerging into this technology for helping the doctors. So this techniques involves a computer aided system for understanding the image structures. So deep learning helps in this process to effective method for dealing with the huge number of problems in the medical image processing. So I have just done a survey on this deep learning models, how it is being used in this research work. I've taken a particular data set for exploring this concept. So here the concept explored using the dataset publicly available Intel and mobile ODT Kahal dataset for cervical detection and classification. Apart from this, there are many other datasets that can be used, but this dataset has been given proper about what are the types of the cervical cancer. So I have taken this dataset for my experimentation. Sorry, for my survey. So there is a literature survey. This author explains about the classification of different types of cervix, and the advantage of this model is that they have used a ResNet model which has been outperforms humans, and it trains deeper into the network. So this
No,
is the
instead of this
advantage.
literature survey, can you focus your work?
Yes, ma'am. Actually, this is a survey, so that
It's a survey paper.
Yes, ma'am. So the limitations of this is it takes a more time to
So for that survey paper also you would have coined, some information.
Yes, ma'am. I will just go fast, ma'am.
No, you can go that. Okay, that is very important for us.
Okay, ma'am. So here we have done a image classification and detection part here in this main. So this area concentrates on the computer vision image classification, which is a subject area of interest. So mainly in image classification, concentrating into deep learning, convolution neural networks is being used for classification in many tasks. So here we will be seeing about the various types of models that have been used. That is Inception V3, Deep SBDD, ResNet, DenseNet, ServixNet, and AlexNet. So by using these models, also we can use pre-trained models for getting a notable results. So first we will concentrate on the AlexNet. This AlexNet has won an SBRC 2012 competition, and it is being a top 5 testing errors rate of 15.3%. So this model is designed using a 5 convolution layers with the 3 fully connected layers. So the advantages of this using this model, it can be both used for image classification and object detection, but mainly it is well known for object detection techniques, which is a wide range for potential applications in computer visions. So in future, this AlexNet,
Now, what
CNN
type
models
of image you are taking? What sort of a image you are taking? Based on what you have done the survey, what type of a image is it?
It is on cervix biopsy images, ma'am.
Biopsy image, what is the format of it?
Uh,
No.
Is it a histopathological images?
Yes, ma'am. It is a histopathological biopsy images of cervix, ma'am.
Is it a histopathological images? How many images have been taken? You told that it has been from the Kaggle data set.
Yes, ma'am. 1481 images, ma'am. It is a type 1, type 2, and type 3 classification of these 3 types of cervix, ma'am.
Is it a multi classification?
Yes, ma'am.
Yes.
3 classes, ma'am. Yes, ma'am. So I have just these papers and all I have been experimented using this particular data set. So I've just explained about it, ma'am. So next is the ResNet model. So in this data set, they have used a ResNet model for classification, which is an it is introduced by the Microsoft Research in 2015. This model is being taken because it is used to address the problems of vanishing and exploiting gradient descent problem, as it uses a skip connections in this. So it can be go straight to the final layer, and it has an advantage of introducing the regularization and bypassing any layers that it reduces the architecture performance. So this problem, this ResNet is advantages. It can result in the vanishing gradient as long as the issues, and it can train very deeply into the neural networks. So then Inception V3 model. So this is used for mainly in the image classification, as this is both for the amount of parameter generated at a cost, and also shows a more computational efficiency than compared to the VGGNet model. So Inception V3 network is used method called convolutional kernel splitting. So this, for example, we are taking a 3x3 convolution, means it can split into a 3x1 and 1x1 convolutions. So this splitting reduces the number of parameters and allowing the network to train process to accelerate, and also it can be retrieved more quickly. So this model is used in one paper, Inception V3. So next, in CervixNet, they have just used this model to avoid the noisy images. So it trains intensely on Laplacian filters, various morphological operations. So this can automatically enhance the images input. So this has been automated in the CervixNet. So this
So in
retrieves
all
the
these models, whatever you have taken, all follow the same format, and based on the same features, everyone they have worked, or what makes the difference?
Ma'am, actually, each model is having a different category. So that about that I am explaining, ma'am. Each model, how they have done the image classification and object deductions. So
The
each model
features,
behaves
the
different.
image
Yes, ma'am.
format remains the same, and
Yes,
the
ma'am.
features also there is a difference.
Yes, ma'am.
Okay.
So here they have taken a region of interest that is done using a mask RCNN for segmentation, and this they have introduced a new technique called hierarchical convolution mixture of expert algorithm to do the classification and segmentation. So next one is the deep SVDD method. So deep SVCD is used, that is expansion support vector. So a method that involves a training the neural network to extract a well as encode common features using a training data. This deep learning architecture is based on one class classification algorithm. So this used for extracting the features from the input and determines similar aspects that have been used to for the goal categories. So this architecture having a 3 convolution models, that is 32, 64 and 128 cross 5x5 filters, which is well as a 256 unit dense layers. So that is being used in the deep SVDD. So advanced one is deep dense net, as we will see that this model will be performing better than all other compared to papers. So this dense net is being a solution for a gradient vanishing gradient problem, and this is connected each layer directly to the next layer, allowing for creation of a dense network. So to maintain the feed forward, each layer receives an exact extra input from all the preceding layers, and it is being passed to the other feature maps to all the following layers. So this network mainly accepts an input of 224 cross 224 cross 3 pixels as an input image, and thus DenseNet are made up of a building blocks that are being densely connected. So as a result, this network will only need to learn a small number of parameters, because all the connections are being extracted from each of the input. So that is what the advantage of DenseNet model. So also this channel or can handle a convolution layer. The number of training data is being reduced, and the feature maps from the previous layer are being concatenated, and this makes the model more compact. So this is the analysis of the existing techniques. So this is a comparison of the various papers have been explained in the previous. So here we can see that so this is a comparison of these models. So we can see from the graph itself that the CervixNet, DenseNet, and Inception models are able to perform well when compared to all the others. So in the conclusion, I am just given that we have done various deep learning methods that are involved to solve the problem of cervix detection and classification. So in this experiment, we can do a fine tuning of the images for more accuracy. So from that we can conclude that by comparing these papers, ServixNet, DenseNet, and Inception have achieved a greater accuracy for all the predictions when compared to the other models. So,
Okay, so
this
you
I
are
have
giving
added.
here that fine tuning, no? So what do you mean by fine tuning
ma'am.
here? What do you want to fine tune here and how you want to proceed? What is this? You
Okay,
have
ma'am.
given some five or six, I think, different type of methods here.
Yes, ma'am. Actually, year after we can
Go to that comparison chart, what you have done.
Yes, ma'am.
Yes, here, analysis.
Yes, ma'am.
So what is that, the accuracy of different study? You have run this and you're giving it, or whatever is existing from their result you have written here?
Yes, ma'am. Whatever they have just done, I have just written here. But I am trying in this, I have selected of 3 models which are being best performed. I am just doing experimentation.
My doubt is that, okay, another thing, what I wanted to, okay, from here you want to proceed, fine. How all the models and all the results you have put in one chart. Do you mean that one thing 58 and another one 62 and another one 96 you are getting? And how it is possible for you to club up all the model together, even though it is a survey paper? So you have to categorize in the different categories, right? So you have just taken the model and just publishing the results of it. How, in what way do you feel that, what sort of work you have done over here?
Yes, ma'am. For some models,
so what makes the difference? You're getting 58 and 62 and 91. So,
this is the
and moreover, there will be feature-wise some technology or what to say, the methodology, whatever they have used may be different. Okay. So you should categorize in such a way that you have to group the analysis into different one. How you cannot write all the 8 together and tell, okay, this is the result.
Okay, ma'am.
Ma'am is asking for your inferences after this thing. What is your inferences after your experiments? That is what is ma'am is asking after your survey. You told that you have done some experiments and you have done something with surveys. Ma'am is asking about the inferences. What is the inferences? Why this is giving 96%? What makes that to give 96%? Why ResNet model is slow? And another thing I want to know about this one is all these are transfer learning technique you have used, or what type of models you have used? How about your ServixNet, CapsNet? Are they are transfer learning technique, or they are working on transfer learning technique, or what?
Yes, ma'am. Some papers they have done using.
Can you list out of these 8 models? Can you list out which was worked under transfer learning and which has been implemented by the authors?
Ma'am, ResNet was just done only on from the scratch, ma'am. ResNet, AlexNet, CapsNet, and ServixNet. But after that, GoogleNet, RetinaNet, Dense, SVBD. Then this is the next 7th one is an N-ensemble model they have used, and DenseNet. These and all used the transfer learning techniques, ma'am. So by using the pre-trained of models, we are getting a more accuracy like that. Okay, ma'am. I can just split it or also and can explain, ma'am. I've just given in one single chart, ma'am.
I have one doubt here. Yes. Whether all the 8 models the data size is same, or and the parameters, yes, features same features you have taken?
Yes, sir. Yes, sir. Same features, sir.
For all these models, same number of number of features,
yes, sir.
And same data set is
yes, sir. So, yes, sir.
Okay. So,
is it true all the models will retrieve same features? Might be the numbers may be the same. Is it true that all the models will retrieve the same features?
Yes, ma'am. All the models, I've taken such papers only for the survey experimentation, ma'am.
How will you prove that all the models have taken same features? Can you prove that one? Whatever features that have been extracted by the model are all same. How can you say like that?
Models will take different features, ma'am. Data set being taken is the same, I am saying.
That's what answer is asking. All the features are same. All the numbers of the features are same. That's what sir is asking.
Amount of data is being taken same.
What is your size of your data? What is the size of your data?
Data set consists of 3 classes, ma'am. All the 3 combined is 1481 images, ma'am.
Will you think that this much of data is enough to prove your system?
Yeah, data size is small, right?
No, no. And
Yes,
one more
ma'am.
thing is that for analysis, only model and the result is being given. The other parameters is not at all concentrated here. So thereby
ma'am.
we can know what is the variation and the other things. So there is no
Okay,
clarity in
ma'am.
this analysis of existing techniques, this particular chart. Only model,
Okay.
result.
Okay, ma'am.
So your survey is incomplete over here because you didn't give all the other features based on, it's not that only based on the accuracy and the model, we give a survey paper. So you have
Yes,
to,
ma'am.
you should work on the different type of parameters, how and what makes the difference between all these things. Because each author, they will have their own view and they would have done it, okay? So you cannot
Yes, ma'am.
generalize everything just like that. Okay, this model they have used in this type of cancer images and they are able to get this accuracy. So this chart is actually wrong, the way in which you have done the survey. Survey
Okay,
has
ma'am.
to be in a wide way, at least 2 or 4, 5 different type of parameters should be there for analysis. With this 2, you can't tell that, okay, this whatever this, for example, the 6th one you're showing 91 and the 3rd you're showing 96. So they have done a very good task and the other 58 has not done the task perfectly. That doesn't mean that.
Okay, ma'am. Yes, ma'am. I get it.
Yes, ma'am. Is there anything to be conveyed?
No, that's
Yes,
all
ma'am.
from my side.
Yeah.
Okay, madam.
ma'am.
We can
Can-
call.
Okay,
Yeah,
call
we'll
the
go to the
next.
You
next.
can go
next
ahead
Yes,
with
sir.
the next
Yeah.
one.
Thank you, sir. Thank you, Hemlata, ma'am.
Yes, ma'am.
Thank you for the presentation. And can you stop sharing your screen?
Yes, ma'am.
I would like to invite the next paper ID 30, live social spacing tracker based on domain deduction. The authors are Divya NK, Mehta, Nirmala Paramanathan.
Ma'am,
Yeah.
my paper ID is the next paper to present a deep learning based COVID.
What is your name, ma'am?
Priyadarshini.
Priya?
Priyadarshini Parmashivamsu.
Priyadarshini?
Yes.
I have given in the chat box, nobody has responded. So that I asked.
I responded, ma'am. I responded. My name
Okay,
is not
we'll just
editing,
okay.
that's why
I got the result from I got the message from Divya one day. Okay, wait, we'll have it in the as the next paper ID.
Okay.
Sorry, Divya, can you?
Ma'am, is my screen visible, ma'am?
Yeah.
Yeah. So, good morning, guys. We have presented a paper, and it's based on live social distancing, based on.
We are not able to hear you.
Please give the slides in the presentation mode.
Am I visible, ma'am?
Yeah, you can put the slides in the presentation mode.
Yeah. So, ma'am, recently the COVID-19 has struck and it has caused infection, ma'am, with the severe acute respiratory syndrome. And, ma'am, the virus has brought the whole world to downfall. So, ma'am, in this, the world was put on lockdown and people were constrained to their
See,
homes.
this is a PPT. Okay.
Yes, ma'am.
And we see here all the references and all the paragraphs from the introduction has been pasted here.
Yes, ma'am.
It should be short and precise.
Yeah, ma'am. I have taken some important points from the introduction, and I have.
No, the
summarized
important points. So many important points are here.
Yes, ma'am. It's somewhat related to the paper, ma'am. Maybe. Yes, ma'am. Hello.
Show the other slides.
Please continue.
Yeah,
We'll do better.
Yeah, okay.
Let him continue.
Yeah,
Please proceed.
Proceed, ma.
Please proceed.
Should I go on the introduction or should I start from objectives?
Yeah, go with the introduction. Yeah, quickly go.
Yeah. So, ma'am, the WHO has considered some public health and social measures which can be used for decreasing the deaths and spreading of coronavirus, ma'am. And one of the such rules is social distancing, 2 feet or 2 feet distance, 2 meter distance is considered as minimum distance that people should keep between themselves to prevent this spread of coronavirus. And so we have made just a detector for that. And in our social distancing detector, we can track the people who are not following these social distancing norm, and that person can be given a warning, or they can in the video it shows a person is marked red or green according to if he's following or not. And thus we can stop and prevent the COVID-19 spread. And ma'am, we have proposed some techniques that that gives better results than the others. Ma'am, in the objectives, ma'am, we have in our paper, ma'am, we have the following objectives. The detection tool should have minimum hardware requirements, and it can examine and analyze any visual data that has given, and it can give efficient results. And ma'am, it should track and warn the people who are not following the social distancing, and also help the authorities to follow the standard WHO protocols, ma'am. The literature survey includes some of the other papers that have been done in the same fields, ma'am. Ma'am, in this, one of the paper was done, and it includes a fire alarm and thermal sensitive camera, ma'am, with person detection. And it in this, the thermal sensitive, when the person enters the restricted region, they create a restricted region, and if the and then calculate the distance. So when the person enters the restricted region, the fire alarm sounds, and thus the person is notified that he's not following social distancing. And same with the other features also, some have used video surveillance and deep learning algorithms to create the same results. Ma'am, what we have done is we have used instead of deep learning, we have used mobile net SSD, because ma'am, it creates a faster recognition rate, and the object object recognition, and it has a faster it produces more data in less time. And ma'am, some are user defined function. Monarch.
Yeah, ma'am. Yes, ma'am. Good morning. Good morning, guys. My name is Monarch Mehta. And sir, we have used some of the function to get our result. We have taken 2 points as a person, and we have calculated equivalent distance between them. And then, sir, we have taken the equivalent distance between the centroid of the person. And if and then, sir, if the calibration is used, and this calibration is used to find the midpoint between the 2 points. And if the statement is true, then distance lies is between the range, as we return false. Divyang, next slide. And sir, this is the step 2, sir. We have used mobile net SSD to recognize the person. Sir, for every frame we recognize the person, and and then, sir, we calculate calculate distance between them to check if they are following social distancing or not. And so the input file will be the video format only, MP4 format only. Divyang, next slide. So this is the main function. So in this, we first of all we divide the we have used immutals library to divide the videos into the many frames, and for each frames we have calculated, sir, the frame per second wave for every for the video. And then, sir, we have first of all, for every frame we have detected the person, and then we have calculated the centroid, and then we have calculated the distance. And if the distance is less than the threshold value, then, sir, we will be showing a bounding box of red mark, else, sir, we will be showing a bounding box of green mark. Hello, Divyang.
Yes, sir. So these are our results, sir. We have used the Python 3 and OpenCV library, and we have taken some standard data sets that we found, and like self video, bridge video, and these are the standard data set that can be used to compare our results with the other results, and thus we can compare all the efficiency and accuracy. This is the formula that we used, and sir, the first component detects the such social distancing interactions, while the second feature detects that if the object is entering a restricted region in there. And so the accuracy of both the characteristics have been verified, and the proposed technique has met all its objectives. Sir, our results, these are our results, sir, and for an example, like we have also made a video as an example for our result, like how our social distancing algorithm works. Sir. This is one of the examples, sir. As you can see, like when the person comes near and the bounding box goes red. Otherwise, if the distance is proper, then it goes green, and so on. The video continues. Sir. These are our references. Yeah.
Already several social distancing tracking models have come. Like many people have published papers on that. So
Yes,
what way
sir.
your work is differing?
Sir, first of all, sir, we haven't used any extra hardware features. Like many of the paper we saw were containing complex systems and algorithms. So we haven't used any hardware. It requires minimum software, and it can run on any software that are present today. And sir, secondly, we have used sir, our recognition time, like we have used mobile net SSD, and it has a time. It has faster recognition rate. So what are video when like if you put the other algorithms, the time lapse that the video, like the processing time is very high, and while our algorithm, the time is very low, sir.
How are you measuring the distance between the people?
Yes, sir.
How are you measuring?
Hello.
Sir, actually we are we are detecting the person first, and then sir we are taking the person's coordinate ID, and we are taking the coordinate X and Y coordinate, and sir and then we are calculating the centroid, and we are giving that person a ID, and for each frame we are giving the person say ID, and then sir we are applying combinations to combination to check the distance between the centroid, and the distance is calculated as equivalent distance, sir.
What algorithm you are using for detecting the object?
Ma'am, we have used mobile net SSD to detect the objects.
Okay.
Did you compare your results with any standard benchmark results?
Yes, we have compared. We have compared our results. And we have published that also in our paper, and it gives a higher accuracy value than the standard paper, sir.
Is this your confusion matrix?
Ma'am?
Is this your confusion matrix? What you have plotted here, what you have depicted here in the slide, is this your confusion matrix?
Yes, ma'am.
What is the meaning of this two? Is it what is the meaning of this two? The static video contains only 2 videos.
No, ma'am. Actually, it is the number of objects that are present. Like in a static video, what we have done is I have to explain some data set, ma'am. In the static video, what it does is like 2 persons are just not moving, and it is static. They are sitting or standing in the video. And true positive is the term for used for the number of person that are recognized in the video properly. True negative is, ma'am, like they are not following the social distancing. That means they are shown red, but the results are proper. Like the person has been identified properly. False positive is, ma'am, like
so the purpose is you need to first identify the object. So your true positive is the meaning that the person have been identified correctly. What is this true negative then?
Ma'am, the person has been identified correctly, but he is not following social distancing, ma'am.
Is this confusion matrix for your social equality and distance measures for this tracking measure?
Yes, ma'am. Yes, ma'am.
You cannot put a confusion matrix for that one, no? For your object detection, you can put, because it is an algorithm, your classification algorithm. So you are putting a confusion matrix to state how about the performance of your model with respect to your data. That has some meaning. How can you put a confusion matrix for your tracking?
Ma'am, actually, ma'am, we are not tracking a single image or a single frame, ma'am. We are tracking a number of frames. Like it is being the video is being processed in the frame. So, ma'am, in every frame, sometimes the person are missed, like when there is a crowd or when there is a number of persons. So we have to track the person. Like we have to, if our efficiency also goes down, if the person is not even identified. So in a crowd or when there are many persons, like the person has to be identified first, and then we have to find the accuracy, ma'am. So then the centroid and all the distances between them is calculated, ma'am.
So that's what I'm asking. What is the confusion matrix? Where you have plotted this confusion matrix? Is it for your object recognition part or the entire system?
Ma'am, entire system, ma'am, entire system.
How can
It
you
is,
put for an entire system? That's what I'm asking.
ma'am, yes, ma'am. So, like we said, in true positive, it means that the object has been identified correctly and he is following social distancing also. In true negative, it means that he has been identified correctly and he is not following social distancing. That is why, ma'am, if you can see the accuracy formula, we have taken it as the numerator. And ma'am,
What
in
you have
false,
mentioned in your content also, it says this accuracy is for detecting the person. You cannot put a confusion matrix for your social distancing tracker. You can put a confusion matrix for your classification, for your object recognition method.
Or else they can give the confusion matrix for two scenarios, no, ma'am. One for one for object detection and the other for
object detection. You can put a confusion matrix, but for
separately.
Actually, this confusion matrix is for our data set, ma'am. We have taken.
Yes, the data set for the object detection, not for the tracking system. You cannot make out a confusion matrix.
ma'am, like object detection.
Ma'am, if actually if the object is detected, then ma'am, the same will be like if the most prior thing is to detect the object, ma'am. After detecting object, the same will be the accuracy for all that.
No, you cannot put a performance metrics for your tracking with the confusion matrix. You can put
ma'am, it is not for object detection, ma'am, because the object detection is primarily carried out by mobile net SSD. So
yes.
yeah, ma'am. So we have used a standard mobile net SSD. We have not changed anything, so we can't put a accuracy result for that, ma'am. It is like for our algorithm, if it is measuring the distance between them correctly or not. If person is
then
tracked,
what is your false positive and false negative in this case?
Ma'am, false positive, that if the person is not if the person is not identified, or it is identifying something else and it is showing a bounding box on that.
False negative is?
False negative is, ma'am, you
have made a mistake, but you want to prove that one that is right. No, it is not right. This confusion matrix is wrong if you are talking for a tracking system. It will be right if you're talking for the object detection. You are saying how your algorithm works for each and every data set. That
Yes,
will be right. But if you are talking this confusion matrix stands for your tracking, it is not right.
Ma'am, it is for our data set
okay.
only, ma'am.
Okay. Ma'am, is there any questions, ma'am?
Okay, you can take up the madam's suggestions and then try to correct your, okay.
Yeah, ma'am. Yeah, sir.
Okay, ma'am. Okay.
Thank you, ma'am. Thank you, sir.
Thank you, ma'am. Thank you, sir.
Can we have the next paper ID 18, deep learning based COVID-19 patients detection? The authors are Paramasivam C and Priyadashni R.
I'm audible, ma'am.
Yeah, ma'am. Can you put it in the presentation mode?
Good morning, one and all. I'm Priyadashini, PhD scholar in Amrita Visva Paper, and along with that, as a part-time and assistant professor in EC department in Padmavati Mahila University. My thesis advisor is Dr. Paramasivam. My paper is deep learning based COVID-19 patients detection. introduction is we are having the COVID-19 patients from far away, to detect that we are using radiographic variants in scanning of the chest, has high deformity and status from the reverse transcription polymer strain reaction evidence for the COVID-19 factor, and coronavirus compared with COVID cases in each body computed tomography looks and determine 98% related affiliate qualifications associated with a minimum of 92%. So detection of this COVID-19 with artificial intelligence makes why prominent means because many patients who comes means the doctor can't able to see that particular scan. So if the scan is there, it automatically detects that the person is having this much of affected with COVID, 98% affected lungs. Like that, it can be detected by you without having doctor means it will be useful for the that is the doctor time will be not wasted, and many patients can't be seen by one doctor, and many thousands patients and thousand scannings can be happens means can't detect by one doctor or 50 doctors, and that will limit the accuracy. So for this we are using back propagation network, neural network to detect this COVID-19. This photographs taking computated tomography models on the chest showed a high degree of disability, and one reported 1041.
See, you have given this tomography chest images, no? So is it
Yes.
available information you did it, or how this is
Available information, ma'am. Available information only I did because the CT scan images is not found. I roughly found data sets from the internet, ma'am. Available.
Okay. So
By
what is
using
this format of the image here? What will be?
What, ma'am?
What is the format of this image?
X-ray image, ma'am. Like that X-ray image.
X-ray
image.
image.
By taking this X-ray image, we are using this previously in paper, convolution neural network is used.
What is the difference then between the X-ray image to the tomography? So is it, I'm not able to understand. Can you just tell me what is the difference? What is the difference between the tomography chest image to the X-ray image?
Tomography chest images have positive conditions of COVID-19.
No, I'm just asking you, what is the difference between an X-ray image to the tomography chest image? So what is that? What is the basic difference between that? Since you have worked in this tomography chest image.
You are asking difference between chest image and tomography.
Tomography chest image and X-ray. So even we take X-ray of the chest image, no?
Madam, normally chest X-ray provides a 2D image, ma'am. While the chest is, it is a 3D image, 3D view of the organs. See, ma'am, I'm
so
using
what device will be used to take this tomography image?
Ma'am, normally the data we are not taking the things, ma'am. That is already existed.
No. Already existing only. I'm just asking you. Do you know that what device is used to take this tomography chest image?
What device we are going to use, ma'am?
Yeah, you are working, right?
Ma'am is asking about the imaging modality.
Pardon?
Ma'am is asking about, I'm just telling her, ma'am is asking about your imaging modality. You are talking about that computer tomography images. No, she is asking the difference between X-ray and computer tomography images.
Okay, find out later. Okay.
We can use CT scans to use.
No, that is not my question. Okay, you can use any thing, but I'm just asking you, what is the X-ray? We know, okay, we know some device is used for taking the X-ray. Like that, for the tomography chest image, what device you will be using?
CT images.
CT scan.
Computer tomography images. It is CT images.
Okay.
Computed tomography.
Okay.
Okay, here the methodology that we are going to use here is we are using this X-ray of that particular patient, and then what we are going to have is this. We are going to make this. We are going to divide this, and then first we have the COVID-19 systematic reports during this evaluation, and all in one. Before that, CT footage was kept in separate areas with high aspirations, and the 3D back propagation neural network model divides specific candidate image blocks, and then the middle image mounted on two neighbors of each strong form is assembled for subsequent methods. And we are dividing this into three categories using the picture request model, compatibility deflection, and the COVID-19. And we are seasonal flu, and then what the respiratory device disease and COVID-19. The image patch that is detected is dominated by a strong and comparison with the candidate type, and the assurance scores will all things can be happens. And finally, a comprehensive evaluate report for this CT test is made subject to noise. And then we are going to have the heart of neural network training is here. The heart of neural network training is back propagation neural network, and it is a method of fine tuning a neural network weights based on the error rate of we are going to make the epochs, number of proceeding epochs. By using the number of epochs, the accuracy may be increased compared to previous paper, that is convolution neural network is used there, and to improve the generalization of model by fine tuning the weights, making it more reliable. By gathering the ideas of this image request model, would understand the form and the structure of modified pollutants, and we are using here good methods for using forwarding weights and selecting capacitance from the edge to relate to information of the aerial image solutions. And the purpose of the combination of contaminants found in serous membrane point can without a doubt we can see that it is a COVID-19, the patient is affected with COVID-19. And then the position of image of aspiration and the right way of the edge is the split that we are going to recollect the condition of the second step. And we are taking this pre-processing, and we are doing the segmentation of that image, and then by taking this image we are going to make that segmentation, and we are going to select one particular thing in this lungs of the X-ray image, and then we are going to make that by making that proper image, we are going to make number of epochs by using this back propagation neural network.
What component
And
you
then
are segmenting from
detect
this one? Just a minute. What component you are segmenting from this image?
we are segmenting the image, that is the period of the image. Any image we are going to select one. In that we can select one any part of this particular image that will detect a number of affected area, what is that thing in pneumonia is affected or not. Then that will detect that the patient is affected with COVID or not. By increasing the number of epochs, we can increase the reliability of that. What the improvements that I am going to have, this assessment model permits fast and powerful acknowledgement of the COVID-19 from chest CT instruction assortments, and a features of higher space rate RT-PCR testing. In any case, many distinctive assessment that took AI models have been beginning late found unavailable motivation for relieving, and determined 98 affectability and 92% disposition. And this program was multi-fated 3D volume assessment of the CT case, scanning case, and the examination is performed higher than one investigator during this paper, considers space affectability and disposition, and essentially the structure of user analysis panel to understand the openness of the COVID-19. This battlefront AI models with merely provided fast and actual knowledge examination for CT is prime for driving clinical specialists. The research gaps and challenges that face while doing this paper is limited availability that we are having in this. The latest and the conclusion is latest development of consolidates artificial thinking and suggestive programming and robots for scattering in clinical centers in line with clinical thought measurable wanting over film global data. As Johns Hopkins University moves during this field, GIS development has become a crucial controversial for this COVID data processing mistreatment. And by using this AI GIS data processing, we can sense extraction square measure ending up being additional priceless and even in region contaminations, preventive lasers, we can use AI nowadays. These are the references. Thank you.
So where did you get the data set? You got it from the open source or any hospital?
Open source, it is having associate degree entire 1,710 image patches, sir.
Okay. Have you compared with any standard benchmark results, your results?
Sir, I compared it with previous papers, sir. It coming what 2% more.
Can you go back to your architecture?
Whether you can early detection can be possible with your module?
No, sir. Early detection is not possible. Sir.
Not possible.
Not used in this architecture.
The next block diagram. You are talking something about candidate region segmentation. What is that one?
Candidate region segmentation means lungs detection by using this scan lung detection 3D model we are used. Here previously we used CNN model. Here we are using back propagation neural network model.
That is what you are telling us. This input is a 3D images, no? So we have slices of CT scans will be taken as an input. So which part of the slice have been affected, which slice have been affected, have been recognized here in this part, or what? The region of
by selecting the region, particular region, we can select, ma'am, that by the image we can drag it by having any direction or any space, we can detect that. We can drag that and then we can detect. We can select any crop, ma'am, any particular.
I am asking you, what is the input? Input is a 3D images, no?
Yes, ma'am.
Is it a single image or the slices of CTs are you taking? 2D slices you are taking, or you are taking a single 3D image?
Single 3D image, ma'am.
Single 3D image. So by segmentation, what you are talking about, you are finding the region of interest where it has been affected?
Yes, ma'am. Yes, ma'am.
How you find that one? What algorithm you are using for that one?
We are using neural network, ma'am, back propagation neural network to detect that. By comparing the number of previously affected images and unaffected images, we are compared by using this back propagation neural network, ma'am. For that, we are using this particular max pooling and many poolings and layers we are using to detect that, ma'am, to compare this affected areas and unaffected areas. We are having the images of both affected persons image CT scans and unaffected persons. By comparing those, we can detect, ma'am. By increasing the number of epochs, we can get effective reliability of that. The person is affected or not.
The work is a classification work, no?
Yes, ma'am.
can you tell me, you are taking 3D as an input image, what you are segmenting? This is the region of interest. The segmented region alone, you are going to give it to a classifier. What classifier you are using here?
Classifier, ma'am.
You are classifying it into 3 different types. Either it is pneumonia or it is a COVID-19. Go back to the name, previous slide.
This one?
Yes.
This one?
This
Yes,
one.
ma'am.
This one.
Yes, ma'am.
Previous slide.
Yes, ma'am. Yes, ma'am.
So what classifier you are using? And this one, what is this classification? What is that classification? The flow says you are segmenting after classification, and then you are finding out the amount of infection in that one. This is what is your flow. This is what is your flow. You are talking about the segmentation. For segmentation, you are saying that you have used back propagation algorithm. I don't understand that one, because you cannot determine, you cannot segment a region using a back propagation algorithm. You have different deep learning models like UNet, where you need to provide a mask, where is the infected position, that you need to train. After training only, for the test image, the affected region can be found out.
Yes, ma'am. Yes, ma'am.
Yeah. That's what I am asking you. What type of model you have used in the segmentation part, and what is your classification algorithm you have used? What deep learning model you use for classification?
Navi's based classifier I use it, ma'am. And
you have used Navi based classifier?
Yes, ma'am.
You go back to the previous slide then. And what is this one? All these max pooling layers, all these one. You are explaining something about your deep learning model, and you are now telling it is a Navi based classifier.
Ma'am, this is the architecture that we are going to use, how we are having the back propagation neural network, and what are the stages and what are the segments for this image.
Okay. Chamu ma'am.
It's over, no, ma'am. Proceed.
Yeah, if you have any queries, you can ask.
Ma'am, you have asked maximum, and I am also convinced, ma'am. Whatever she has said, okay, we will proceed with the next paper.
Can we move on to the next paper, sir?
Yes, madam. Okay, madam. Go ahead.
Oh, thank you for your suggestions, ma'am. I will improve whatever the ma'am said, that I will put research on that work, ma'am.
Okay, ma'am. Thank
you. I
you.
will improve more knowledge about this. Thank you.
Okay.
Thank you.
Yeah, and the next paper ID 46, classification and prediction of lung cancer with histopathological images using VGG19 architecture. The authors are Saranya N, Gandhimati N, Bhumika S, Bavadarni S, Karthik Raja R.
Yes, ma'am.
Ma'am, what is the paper ID of this paper?
46, ma'am.
Is this visible to you, ma'am?
Pardon me?
Ma'am, is this visible to you, ma'am?
Yeah, it's visible.
Yes, ma'am. Good morning, Anandal. Myself, Karthik Raja, and my teammates are Bhumika and Bhavadharani. And we are from Banari Institute of Technology. Here we are going to present a PPT on classification and prediction of lung cancer with histopathological images using VGG's 19 architecture. So the problem. Nowadays, lung cancer is one of the most serious cause that leads to death of the humans. Here, our problem statement is to reduce the death rate of cancer affected patients by diagnosing earlier using deep learning techniques.
It is considered as the most dangerous cancer worldwide with the lowest success rate following diagnosis. The solution. Normally, cancer is found at an initial stage. Therefore, when it is small and before it spread through the lungs, it is more likely to be treated successfully. Here, we are using using the pre-trained VGG19 algorithm to train the CNN architecture for classifying the different stages of lung cancer in an efficient way. By using confusion matrix along with the heat map generation, desired accuracy of model is predicted. Objective. The main intention of the proposed work is to classify and predict the lung cancer using deep learning techniques. By the help of latest model technology, we put forward the model to diagnose lung cancer as soon as possible. Another objective of our work is to reduce the time complexity by increasing the accuracy of the detection and make the work easy for the medical physicians to detect and diagnose patients with lung cancer. And our scope. Main scope of our project is to attain accurate prediction of lung cancer and to treat it earlier. Nowadays, different types of cancer and its classification using machine assistance has shown the better ability to reduce manual system impairments. Finally, our ultimate aim is to reduce the death rates and to increase the lifespan of the patients that are being affected by the lung cancer.
Next is the need for current study. The early and accurate prediction of
you can cut this literature survey. Go ahead with your work. They got disconnected, yes, madam.
No, ma'am, they are here only.
Okay.
Yes,
okay.
Karthik Raja, go to how it works slide.
Go to your work. Okay.
Okay.
The first step process is data acquisition. The data sets are collected from online source. It has a useful as a means of visualizing and classifying. The data sets
tell me from where you got the data set. What is your size of the data set? How many images are there? And what type of classification you are doing? Is it a multi-class or subtypes of cancer you are finding out? Can you list it out those things?
The data sets consist of 5,000 histopathological images, ma'am, with three different classes.
Can you list out the classes?
Lung cancer adenocarcinoma, lung cancer normal, and lung cancer squamous cell carcinoma, ma'am.
Okay, thank you. Let's proceed.
And the data argumentation is the number of samples will have a significant impact on the performance of the model. Argumentation is a technique. It is used to enhance the data quantity and increases the complexity of the samples. And argumentation is performed on 5,000 images and enhances into 25,000 images to acquire better accuracy. The next one is a transfer learning. Transfer learning reuses already acquired knowledge gained from pre-trained VGG19 model in previous stacks, and it is used to improve the generalization with new data. The next step is classification. We are classifying the trained images in order to test the model accuracy. The last step or process is prediction. By using heat map generation, the prediction of presence and absence of lung cancer was done. Next is design. This is our design for a project that is VGG19 architecture. It is an optimized VGG model. It consists of 19 layers. And it is classified in this network. It is classified into 1,000 images, each images with 19 layers. The layers are 6 convolution layers, 5 max pool layers, 3 fully connected layers, and 1 softmax layer.
The next is a result analysis. We have taken the training and validation set in the ratio of 80:20. And the epochs indicates the number of passes that the learning algorithm will work through the entire training data set. Here we have taken 10 epochs for our project, and we have analyzed the results for each epoch. Finally, we have gained an accuracy of 95.8%. The next is the plots and plots of accuracy and validation. Next, this is the plots of accuracy and training and validation accuracy and loss over training epochs. The next is confusion matrix. With the help of confusion matrix, we are predicting how many images are predicted correctly and how many have been predicted wrongly. The evaluation parameters such as precision recall F1 score are used for calculating the accuracy performance matrices rather than the normal accuracy analysis methods. The modern tool we have used is Keras TensorFlow. It is an open source artificial intelligence library. And we have made our compilation, building and running our architecture in a Jupyter notebook platform. Next, these are the references we have taken for our project. And that's all, ma'am. Thank you.
Yeah, go back to the ResNet architecture, no?
It's VGG 19, ma'am.
Yeah, sorry, VGG 19.
Okay, no.
Yeah, you are talking about a transfer learning technique. Have
Yes,
you fine-tuned your model with your new data, or what you did?
Yes, ma'am. We have fine-tuned our model with the new data because in previous studies they have calculated for only VGG 16, ma'am. VGG 16 ResNet, and then we have taken VGG 19 for our model, ma'am. They have mostly they have done for CT and X-ray images, but we are doing it for histopathological images, ma'am.
So, how many layers you have fine-tuned?
Ma'am.
Because this is a transfer learning model where it has been worked for an ImageNet, I think so. ImageNet data set.
Yes, ma'am.
Yeah. So there you have different classes. Now we are talking only about 3 different classes.
Yes,
so
ma'am.
Have you fine-tuned it? Are you using as a feature extractor? This model have been used as a feature extractor or a fine-tuning model? If you have fine-tuned it, how many layers you have fine-tuned with your data set?
Ma'am, we have feature extracted only, ma'am, because we have trained our model based on the images, based on the 3 types of images, ma'am. So we have fed that three sets of images to the model.
You fed 3 sets of images. To which extent you have fine-tuned? I am asking. How many layers you have freezed? How many layers you have unfreezed? So freezed layer you cannot train.
Yes, ma'am.
Only the unfreezed layers can be trained.
Yes, ma'am.
I am asking you for how many layers you have trained with your new data. That is what is the transfer learning technique, no?
Yes, ma'am.
You have already existing model. You will be using a model for your new data. You can either fine-tune it for certain extent. So I am asking you for how many layers you have trained your model with your new data. Or you have removed already existing model classifier and you have attached your own classifier.
Ma'am, 19 layers.
There are 19 layers in VGG 19. That's why it's got the name of VGG 19. I am just asking you with your new data, how many layers you have trained? You have not trained, you have taken only already existing features and then you have your own classifier. What is your input layer, output layer thing? What is the activation function you have used? What is your output layer? Can you explain about your output layer of your model?
Ma'am, softmax we have taken.
Okay.
Our output layer is dense layer.
Dense layer with how many neurons? You have added that dense layer or it is already existing dense layer in your VGG 19?
4 neurons, ma'am, dense layer, 4 neurons.
But you are talking about only 3 classes, no?
Yes, ma'am.
Then?
Ma'am, in last layer, we have used 10,000 neurons, ma'am. Ma'am, actually, we have trained the already existing VGG 19 architecture, ma'am. So
what you can do, ma, because you are using your own image. You are
yes,
using
ma'am.
already existing model. That is what is a transfer
We
learning
have not
technique.
made any changes in the
But
architecture,
you
ma'am.
cannot
We have,
use like that, no, ma. This VGG net have been designed for an image net data set, which
yes, ma'am.
consists of n number of images. I don't know what is the correct classes used in the ImageNet.
Yes,
So it
ma'am.
is a generalized image used in the ImageNet. This have
Yes.
been designed for the ImageNet data set.
Yes, ma'am.
So you are, it's true that you have used that model. So you have
Yes.
taken all the weights that have been extracted from the ImageNet data model. That's I know.
Yes.
But I am asking you, how about your final layer? Have you modified the final layer? If you have modified the final layer,
No,
what,
ma'am.
what is your thing?
We have not.
ImageNet when the 1,000 classes, if ImageNet is 1,000 classes, there should be 1,000 neurons in the output
Yes, ma'am.
class. But here we have only, we need only 3 classes, no?
Yes, ma'am.
Then how come you use that one here? You cannot use it.
Okay, ma'am, but the images can be of different sizes and different weights, no, ma'am. So how can we give that images in a 3 types, ma'am?
Ma'am, you are telling your input is for a histopathological images to
Yes,
classify
ma'am.
3 different classes. Then
Yes,
your
ma'am.
classifier should do that 3 different classes only, no? Not for 1,000 classes, no?
Yes, ma'am. But if different types of images has been given, means it want to predict. No, ma'am. It's not an histopathological.
It has to be modified. The last layer to be modified. That is what is said to be a transfer learning technique. The earlier layer weights will be taken because it is an image. All general properties from an image will be the same. So it will take all the earlier layers. I need, if I want to do any fine tuning, I can do only for the few layers of mine.
Okay.
Based on my input.
Sorry, ma'am. We are not aware of that. We will work on it, ma'am.
Go and check it out. It will be there. You didn't found the, you
Yes,
are not
ma'am.
able to present it now. It will be there. You have done. Then only you
yes,
will get an answer for this one.
Yes, ma'am. We
Go
can't
and check it out.
Okay, sure, ma'am.
Sir, can we
whether
move on
your
to the next one?
Whether your model can predict the different stage of the cancer, like advanced stage or preliminary stage, like that?
Yes, sir. The thing is, the 3 different classes are also different stages of cancer only, sir. In adenocarcinoma also, it has normal, abnormal, and then the advanced stage of cancer. So
you are able to predict the
yes, sir.
The severity of the disease also.
Yes, sir.
Okay. So prediction accuracy is better than the existing models. Any?
Yes, sir. Normally they have obtained up to 92%, sir. We have gained.
Did you have any comparison with any check benchmark results?
How
did you validate your work?
Sir, in most of the research papers, they have not used histopathological images, sir. So we have compared it with CT images, and most of the papers have not gained up to the level of accuracy, sir. So.
Okay. Pick up madam's suggestions and incorporate those.
Sure, sir.
Yeah.
Thank you, sir. Thank you for your suggestion.
Okay.
Thank you, ma'am. We'll work on it, ma'am.
You worked on it. You didn't know how to present that one. You just go back and check your code. There will be different layers. There will be 3 neurons in your output layer. You have modified that one.
Okay, ma'am. Sure.
You can check it out.
Sure, ma'am. Thank you, ma'am. Thank you for your suggestion, ma'am.
Yeah, we'll go to the next presentation.
Okay, sir. Okay, sir. Yes, paper ID 47. Analysis of the impact of white box adversarial attacks in ResNet while classifying retinal fundus images. The authors are Bharat Kumar DP, Nanda Kumar, Snowfi D, and Mary Anita Rajam.
Good morning. We are ready. Can we share the screen?
Yes, yes.
Okay. Is the screen visible, ma'am?
Yes.
Okay, I will start the slideshow. Can I start, ma'am? Okay.
Yes.
Okay. So good morning, everyone present. Our paper title is Analysis of the Impact of White Box Adversarial Attacks in ResNet while classifying retinal fundus images. Okay. So what is adversarial attacks? Adversarial attacks are malicious attempts to perturb an input sample and fool the ML model to classify it into something else. We tried white box and targeted attacks. White box attacks are attacks where the architecture of the model and parameters are known to the attacker. And target attacks are attacks where we are pushing the input sample to a particular class. If you see the graph on the right, there are two types of inputs, which is affected and unaffected. This is the classification boundary which separates, which does the classification. The two red dots to the bottom left, these are classified by the model as unaffected, even though it has not seen any samples here. And this is where the problem lies. Adversarial attacks, deep learning models are vulnerable to adversarial attacks because of this linearity hypothesis. And we did experiments to understand the effects of perturbation added, and also a few modifications to the existing attacks are tested in the paper. And we took a medical diagnosis problem, which is the diagnosis of diabetic retinopathy. It is a complication of diabetes mellitus, which causes lesions on the retina. It is usually diagnosed by ophthalmologists to manually inspect retina images and like classify if a given retina image is a diabetic retinopathy affected or unaffected. And this is time consuming and also sometimes prone to errors. And deep learning models are found to be efficient in classifying, and also like if accuracy is very better than than what normal people do. So deep learning models are applied for this particular diagnosis problem, and we implemented adversarial attacks on this particular use case. Literature survey. The first adversarial attack was shown by Skezdi Heddel, and he used a method known as
you can go ahead with the next one. Literature survey is not required.
Okay. So the first attack we considered was LBFGSB method. So what it does is, given an input image X, so what is the aim is, given an input image X, our aim is to find an adversarial input, which is X dash, which is very close to the given input image, and also it is classified as a different class. You see X is the given actual image. We find another input image X dash, which is very close to X, but also f of X dash is not equal to the actual class of X. That is the aim of this attack. But this optimization problem is intractable, and this problem can be hard to solve because it is highly nonlinear. So hybrid loss function is created. This loss function is what is shown here in this formula. It comprises of two terms. The term to the left computes the norm. Norm is actually how much the perturbed image is different from the original image. That we are computing Euclidean distance between X and X dash and squaring it. And C is a constant. And the term to the right is a loss. Which computes the loss function when X dash is given an input, and we're trying to make it classify as L, which is a target label. So our aim is to make X dash to be wrongly classified as L, and so we are trying to minimize this loss term. We are combining both these terms, and our aim is to minimize this. And the constraint is that we don't want the perturbation to be too much away from the actual input. That's why we want X dash to lie near to the actual X. And this method is called box constraint because the constraint for X dash is actually a box surrounding the actual X. The method is, this method is actually can be expanded as low. BFGS is actually a method, second order optimization method, which was found by 4 authors. And L stands for low memory because this is an optimized version of LBFGS method. And the final B stands for box constraint. So this is the optimization method which is used to implement the attack. This is an existing attack, and we made a small modification. What we did was we removed the norm constraint, that is the left term in this expression. What we hoped is that if we just optimize the loss function alone, then we would get better results. That is, the adversary will be more confident. And if the perturbation is not very much, which means that if the perturbation is not visually seen by humans, then this may produce better results. Results are in the upcoming slides. The second attack is FGSM attack. It is expanded as fast gradient sign method.
See, in the previous attack, okay, so there is a loss, okay, and this is the optimization problem. So what sort of a change you did here? Did you work on this particular attack, and is it still an optimization problem you underwent, or some other way you used? Only the loss function alone you eliminated?
Yes, we kept it as the same optimization problem. We just removed this term, this left term. We just removed this norm constraint. So initially it needs to minimize the sum of these two terms. We removed the left term and we just try to minimize this loss function alone. Because we don't want to we thought that if we remove this norm constraint, the optimization process will be more efficient. And we just want to see how much perturbation is done to minimize the loss. If the perturbation is actually not that much, that is, if the image produced is not very much distorted, then it might produce a better adversary than this previous method.
Okay, what is the loss function you used here?
Loss function is cross entropy loss, ma'am. That was actually used in the LBFGS method, and we tried to maintain the same.
Okay. So you have used this attack, and the data for this particular data, you how you managed?
Sorry, ma'am. Can you repeat?
At data, okay. So what sort of a data you used for this particular attack, and how did you calculated this loss function?
Okay, ma'am. So this loss function is cross entropy loss is actually log. It involves a formula which takes an input image as which takes as input the input image we are giving. That is, retina image is actually the input, ma'am, to the loss function, and another input is the target we are classifying. Here the target is L. So X dash and L are the inputs given to the loss function. It computes a loss. It's a normal cross entropy loss which we use for other machine learning models.
Okay, actually that is the adversarial point. No, so how did you take those data? Input image is retina image. Okay.
Yes,
so you have the X dash is what you are supposed to find, but that X dash you are giving as as the input for this particular loss function. So what you did?
Okay, so we are minimizing, ma'am. X dash, the optimization problem is about trying to minimize this loss function, and the parameter which we are changing is X dash. We'll keep on changing X dash till we minimize this loss function. And also there is a constraint. We can't keep on like changing X dash. We need to maintain this box constraint which is given in the second line. X dash should be between 0 to 1, which is a box. Like actually, X dash should not be very much different from X. So X dash is the parameter which is optimized here. Oh, sorry, X dash is the parameter is changed here, and loss is optimized.
Okay, so X image is going to remain the same. So the loss data you gave your based on some assumption, okay, some maximum and the minimum value you had, and based on that you were trying to minimize.
Yes, ma'am. We're trying to minimize loss by changing X dash.
Okay.
And if you get a minimal, like if you get a minimal loss with that X dash, that X dash should be the is the actual adversary. We have created adversary which is wrongly classified, and all because we have moved till the minimum loss. So it should also maintain this constraint that is given in the second line.
Okay, how will you maintain that loss is has reached this adversarial point?
Sorry, ma'am.
How will you keep track? Okay, that is, this is the value. How will you fix this value? That's what I just wanted to know.
How it identifies this value?
Yeah, that minimum value, maximum value you're taking. No, so how did you judge those points?
This constraint, ma'am. Okay. This constraint is actually determined. There is a parameter called epsilon, which we have used in the form while programming. So this epsilon value will determine we can take a middle value, and we can move on both sides. Like we can let's say x is the middle value. We can go till x plus epsilon and x minus epsilon. These are the range. Like epsilon is a parameter which we can choose. Which can be changed. So we took a random epsilon value, and based on the epsilon, we created a box constraint. So we can allow x dash to lie within that range, x minus epsilon and till x plus epsilon.
Okay, so go ahead.
Okay. So the second attack is fast gradient sign method. The basic idea is to perturb the input to maximally change the loss function of the model. So what we do here is, using gradient descent, we find the direction in which the loss descends steeply. So like using gradient descent, we find the direction at which the loss descends steeply, and so we push the inputs in that direction. How much amount we push, that is determined by a parameter called as epsilon here. So I repeat, this computes the gradient of the loss with respect to the input, and this finds a direction at which the loss decreases steeply.
So in this case, did you apply as such, or you did some variation here?
FGSM, we applied the same as mentioned in the paper of the authors.
Okay, so for this particular attack, you did the same operation.
Yes, ma'am.
No change in the loss function.
No change in the loss function. Because can I proceed, ma'am? I'll tell the reasons for.
Okay, go ahead with the next slide. Let us see.
Okay. Just one more point about this FGSM. This
Yes.
FGSM is actually faster than the LBFGS, and this is just a one-step algorithm. The previous one we need to iteratively keep on searching, but here we just like do this one addition. Like after finding this epsilon times the sign, if we just add it to the normal text, we'll get this x dash. So this is primarily designed to be a fast method. This might not give more like, that efficient result as the previous one. So this is primarily designed for giving fast results.
Okay, so the last function you are adding it to the retina image value, whatever you are having,
yes,
and thereby you are deriving the x dash.
Yes, ma'am. This X is the original image, and this is the perturbation we're adding. We're adding some noise kind of. So, like when we add both, we'll get an another image. This is the actual perturbed image, X dash.
Okay.
And this is ResNet. ResNet model is ResNet 50 is a model we chose to implement all our attacks on. This is the deep learning model on which all the attacks were implemented. And ResNet 50 is a variant of ResNet with 48 convolutional layers along with one max pool and one average pool layer. And we also added global average pooling, dropout, and dense along with the already existing ResNet 50. This is the architecture we used. And we loaded, we used transfer learning and loaded with pre-trained weights from imaginary dataset. On top of that, we trained with retinal fundus image dataset, which was actually about 18,000 images. It is a binary classification problem, so equally split as 9,000 affected images and 9,000 unaffected images. Okay, next. So attack framework, how we actually designed the attack. What we did was we took 100 input samples that were actually correctly classified by the ResNet model, that I showed previously. So 100 input samples which are actually originally classified, and we implemented the attack on these 100 samples. And after implementing the attack, I again like classify them and I'll analyze how much were wrongly classified. So to get an idea of how the attack was efficient. And it is a binary.
Actually, you have some two different type of an attack, no? So how come here binary classification you are telling?
Binary classification is actual problem, ma'am. You given a retina image, it classifies it as either DR affected or unaffected. So the actual
okay. So it is not with respect to the attack you are claiming.
It is just with the problem, ML classification problem alone. It's binary. Attacks is different.
Okay.
And it is a targeted attack because given an unaffected image, we're trying to push it towards affected direction and vice versa. And distance metric is if given an input image and a perturbed image, we need to measure its difference. For that I'm using L2 distance metric. Otherwise, we can call it as Euclidean distance. I'm just computing the Euclidean difference between the two images. If the difference is more, then it means the perturbation is more. I'm pushing the images too far.
This distance metric is based on the outcome or how?
Okay, so there are actually a number of distance metrics that are used in the literature, ma'am. So one was L0, L2, and L infinity. L2 was seemed to be like the best one for the attacks we are trying now, LBFGS and FGSM. So like there are multiple distance metrics which can be used. Euclidean is one such, and we found it to give good results for that.
Okay.
And these are the results we got for the first attack, ma'am. So the same problem we are implementing with both attacks. So first is the LBFGSB attack. I'll explain the metrics we use to evaluate the attacks. First is the success rate. So what success rate is that given 100 input images.
Data set you used here for this particular attack, and where did you got this attack data?
Okay, ma'am. So attack data set is there is website called IDRT where they have given all the retina images, ma'am. So we used that data set. And we didn't like for implementing attacks, we took only 100 images because we just want to we want to measure the efficiency of the attack. So we just took 100 input samples which are originally.
And ResNet model was able to produce very good output for the 100 rows.
Initially training process, we trained with the entire data set, ma'am. But for just implementing and testing the attacks, we used 100 samples. These 100 samples are just for testing the attacks.
For testing, okay.
Yes, ma'am. Okay, so the parameters like success rate is out of 100 images, for how many images the attack was successful. So if it's 61%, it means 61 images the attack was successful. And also confidence is how much confident the model was when misclassifying the adversarial image. So how much confidence was it when wrongly classifying it. So there are 100 images, so we took average of that 100, that is average confidence, and max confidence is out of this 100, which what is the maximum confidence that the model. Confidence can be otherwise taken as accuracy, like how confident was the model in predicting that particular sample. And norm is the distance metric, L2 distance norm. If norm is high, it means that the perturbation is more and the image may be visually distorted. You can see the image here. It's actually the perturbation is very high. That's why you could see like there are slight distortions on the corners of the image. This means that the image is actually very much perturbed. This is the average norm and this is the maximum norm. Strong adversaries is like, let's take like an example, ma'am. X is the original image. It is actually classified with let's say 50% confidence. But what happens is that we create an adversary from X, which is X dash, but that is classified with a higher confidence, which is 99%. So this may sometimes happen. Like it misclassifies more confidently than the original classification.
So this strong adversaries is based on the X dash value you are claiming is 36, 71, 99. Is it something like that?
Which one, ma'am? X dash value?
The last strong adversaries you are telling, no?
Yes, ma'am.
These adversaries, are you predicting based on the attack that is 36, 71, 99, 100?
No, ma'am. Actually, this is a count of like out of the 100 images, 36 were strong adversaries, which means that these adversaries were more stronger than like they were more confident than the original classification itself. For example,
no, how this data was already existing, or you worked on this one?
On this, we got the results because we know the initial classification. Like we know that what confidence was got with the original image. So we compared it with the confidence we got after perturbing. We compared them, and if it is the perturbed image got more confidence, then we call it as a strong adversary.
Okay.
Okay. So can you proceed, ma'am?
Okay, fine.
Okay. So these are the like metrics with which we analyzed. If you see, epsilon is a parameter which we can change. So if epsilon value is higher, it means we are perturbing more, and that's why the norm is very high. If you see for 0.07 epsilon, norm is very low, just 29 and 31. Norm is we are perturbing very little. But for epsilon 1, we are perturbing a lot, and that's why it is 346, more than 300 times. And also the confidence is high because when we are perturbing more, we are pushing the image towards that target. So that's why we are able to easily attack, and we are getting a lot of confidence in the misclassification. Also, success rate increases as we increase epsilon, and strong adversaries also increases. Strong adversaries are 100, which means like all the 100 images attack was successful, and all are strong adversaries. So the top left table was for the original attack. This bottom one is the modification. We said we made a modification, and results results are in this bottom table. Here, if you see, like one observation was that confidence was higher. Like even for 0.2 epsilon, the confidence, average confidence and maximum confidence are more than 90%. Here it was only 76 and 96. So we found that confidence increased as we expected because we are only minimizing the loss function. We are not worrying about the norm. So it tries to push as much as possible, and that's why confidence is higher. And also the drawback is that norm has also increased. If you see for 0.2, the norm is very low here, only 70 and 75. But here it is increased to 146 and 301. So like we are giving a cost. It is like a trade-off. If we allow norm to go to higher values, then we can get more confident samples. And so we thought that if the application doesn't demand a very low norm value, then this method could be useful. Like we can give the cost of higher norm, but we get more confident images. And strong adversary.
Your argument is that you were able to apply that loss function. With that loss function, that is in the optimization function, with the loss itself, you were able to identify the strong adversaries. That is what you mean by?
Yes, ma'am. Optimizing only the loss function, we got these results, and these results gave better confident values than the previous one.
Okay.
But it also increased the norm value. So it's like a drawback law. If people can't accept this high norm value, then this method might not be useful because norm values, increasing norm value might make the image distorted. So if people can easily understand that this image is perturbed or attacked, then
one more thing here. You are giving strong adversary as 100. So what is the meaning in that particular one?
Okay.
Because adversaries normally we will not give strong, right? 100% is not correct, right? Adversarial can be in different levels, different results we need to get. Okay. So in what way this 100 adverse will be correct one?
Okay, so what it means is that give out of the 100 images, all 100 but strongly misclassified, ma'am. If you see the average confidence and max confidence are all 99. For example, let's say X is the original retina image, ma'am. Its original classification, like without any attack, it is being classified with 80% confidence. But after after this LBFGS attack, it is classified with 99% confidence. So this is a strong adversary, and this happens for all the 100 images, ma'am. So I give
my thought is that the strong adversary should not be 100.
But it depends on the confidence value, ma'am. If all the images.
No, that is what I don't know how that, because what is an attack? Okay. So that particular attack cannot be 100% for every one of them. And it is going to be varied for the different categories. By using this loss function, okay, I don't know how this is going to be useful. Okay. That strong adversary data 100% is going to be correct.
Okay, but 100% the confidence value might not be same. It may be different. And you can see in the top, the previous method, we have got adversary like 36, 71. It was gradually increasing to 100 because the confidence values were lower. Here only 66% is the average confidence. So it means only 36 images met this condition. But here all confidence values are higher because we didn't care about the norm constraint.
For your thing, okay, everything there is an improvement. Okay, I agree. But adversaries, that is, it is not, we cannot say that 100% that may be a correct one. Okay. So that is what is my claim. Okay. Okay, you can,
we
can check out that later. Okay, just go ahead with the next slide. Okay. Because we don't have time.
You can discuss offline with madam also.
Yes, sir. Yes, sir. Yes, sir.
Yeah. Because we are running out of time.
Okay, ma'am, I'm moving on. So the next attack is FGSM. The results of FGSM are given here. Here, one observation we found was that increasing epsilon values to very high values decreased. Here, epsilon is again a parameter. So if we increase epsilon value, we are taking large steps in the direction, and so high confidence value adversaries will be produced. If you see, as we increase epsilon, success rate increases, and again the confidence values are increasing, and norm is also increasing. But one observation is that if we increase epsilon too high, then success rate reduced. We found the reason to be because if the epsilon is higher, then the steps will be larger and convergence of gradient descent is prevented. So that's why it's not able to find an optimal value. And also, if you see that like overall, it's not able to get 100% strong adversaries because this method is not that efficient as LBFGS. It is just designed to be more faster than that. Okay, so next is we did some experiments with noise perturbation. So what we did was, this is the perturbation that we added, ma'am. In FGSM, I said we are adding along with X, we are superimposing an epsilon times sign of that term. So this is we extracted it and we printed it. This is what that the noise, that perturbation looked. So this was created while trying to push an DR affected image to unaffected image. What we did was we tried to impose attack on this itself. We model doesn't know if it's an or normal image or not. So we try to impose attack on this perturbation image itself. So this perturbation image was initially, as it was trying to push towards unaffected direction, it had some properties of an unaffected retina image, and that's why it is classified as unaffected. And when we imposed this LBFGS attack on that, the attack was successful and it was classified as DR affected. And the observation to note here is that it required high epsilon value, which means this was not just a random noise. What I mean to conclude here is that the perturbation that was added for attacks are not just random noise. It holds some properties of the unaffected retina image, and that's why this attack was very harder. Whereas for a random noise, this is a random noise, the bottom one. We are able to, this attack was easier. We got the attack successful with a small epsilon value, but here we needed a larger epsilon value. So my the conclusion we come here is that the perturbation, that is the perturbation we add in the attacks, is different from random noise. It's not just random noise we're adding to make this attack successful. These are carefully designed so that to push an image into the particular target class. Next one. So adversarial direction. I said about adversarial direction, which is the direction in which we need to push to make attack successful. So in Goodfellow et al., he made an hypothesis that only the perturbation direction is important, and it is same for all samples of a given distribution. Which means if you use this is a perturbation we got. I got from a different sample A. I'm superimposing it on a different sample B. So this perturbation is got from another sample. I'm superimposing it on a different sample. So what I expected is that this attack should be successful and it should be classified as unaffected. but like it couldn't implement the attack, but still the efficiency decreased. If you see confidence decreased, here it is 77%, but superimposing this image reduced it to 74.89%. So it means this perturbation tries to push it towards the unaffected direction. So this proves the Goodfellow results claim that adversarial direction stay the same. Like you can use this perturbation on all input samples and still get the result. Okay, and again, some properties of adversaries. The perturbation depends on epsilon values. I try to plot, extract and print the perturbations for different epsilon values. You can see that the images are different. As epsilon values keeps increasing, the images are different. Okay, on the defensive side, we tried 2 defense systems. So till now we saw about attacks. We saw about 2 attacks, and I also tried to test some defense methods also. One defense method was adversarial training. Idea of adversarial training is we got some adversarial samples. So let's retrain the model again with this adversarial examples with the correct labels. So we are making the model to learn the adversarial examples also. We used FGSM adversarial inputs because FGSM creates adversarial inputs faster. So we used it to retrain the model. And we found that it's a good regularization step because it actually increased the accuracy of the original model itself. And it was also a hypothesis in Goodfellow paper where he said it is a good regularization step, better than dropout. So instead of dropout, you can use this adversarial training itself for normal machine learning itself. We found it through our results. I'll show it in the next slide. These were the results we got for adversarial training. These were the results we got after training. So if you see the confidence value is very low than what we saw in the previous FGSM attack slides. We saw that it was about 99% like for epsilon 1, but here it's only average confidence 55. Max confidence is still higher, but average decreased, which means like a lot of samples got their confidence values decreased. And also strong adversities dropped to 0, ma'am. So like most of the samples had very low confidence values, and this means that attack was good. It made the the defense is good. It made the attack very tougher, and that's why we got strong adversaries all zeros. And also this is the result with LBFGSB. Here also you could see strong adversaries decreased to 0, and also but here the confidence values were not that different as we saw with FGSM. So these were the results we got. Main observation was that we are able to reduce the confidence values and make strong adversaries 0 with this adversarial training defense. And the last defense we tried was defensive distillation. This was a totally different method where we trained 2 networks. One is a teacher network, which we train with softmax output of temperature 100. This is a softmax function. Here we set the temperature T to 100. So this will create soft labels. And we use these soft labels to train another network called student network. And that model is more robust. Like if you see the results here, this is the success rate of attacks before this distillation. But after distillation, we like reduced the success rate to this much. Like from 99, we reduced it to 60, and from 100, we reduced it to 82%. So this defensive distillation is another defense method, and these are the results we got for both the attacks. So finally, this paper aimed to demonstrate the applicability of adversarial attacks. So like not just this image classification problem of retina images, this can be applied even for self-driving cars, where we need the camera and the self-driving cars need to identify the road signs, and also malware classification. These are very crucial examples where adversarial attacks are possible, and it needs to be handled critically. We also briefly explained the problems in each of the attacks, and general ideas were discussed to solve them. We tested the arguments related to FGSM and verified the importance of adversarial directions with the experiments we did. And these are the references. Thank you. Any questions, ma'am?
Yeah.
We're happy to answer questions.
Okay, for my side, it's okay, ma'am.
Okay, ma'am. Sir?
Yeah, you can proceed with the next batch.
Okay, then thank you, Bharat Kumar. Thank you for your presentation. Yeah, paper ID 54, perspective review on deep learning models to medical image segmentation. Hartlin Maria, A. Maria Joshi, and S. Malarvili.
So good afternoon all. My name is H. Hartlin Maria. I'm a research scholar from Department of ECE, SRM Institute of Science and Technology, Chennai. My research supervisor is Dr. Maria Joshi A and Dr. Malarvili A from SRM. Our topic is perspective review on deep learning models to medical image segmentation. Our objective is to perform a detailed perspective review on the various CNN variants available for medical image segmentation and thereby build a custom deep learning model for segmenting ovarian tumors. Introduction. Ovarian cancer is the third most common gynecological cancer in Indian women. In 2020, the new estimate of ovarian cancer cases in India was said to be around 59,000. The symptoms of ovarian cancer include abdominal bloating, weight loss, discomfort in the pelvic region, change in bowel habits, etc. Ovarian cancer is said to often go undetected until it has spread within the entire pelvis and the stomach region. So the only hope lies in early detection and treatment of the disease. The risk factors include...
So are you planning for early detection now?
Yes, ma'am.
Okay.
In this work, we haven't added the stage-based results, ma'am. This is basically a survey work, but however, we've added our preliminary results at the end, ma'am.
Okay, okay, please proceed.
Yes, thank you. So these are a few of the risk factors involved in ovarian cancer. Women who have never been pregnant have a higher risk of ovarian cancer. The carriers of BRCA1 and BRCA2 gene mutations, women with an early menarche and a late menopause, and women with the history of breast cancer have a higher risk of ovarian cancer. So ovarian cancer cannot be, researchers have concluded that ovarian cancer cannot be confined or termed as a single disease because it has various subdivisions based on the cell of origin. And under that, we do have type 1 and type 2 classifications. So in this work, we have focused specifically on epithelial ovarian cancer of type 2. Why we have narrowed it down to this type 2 ovarian epithelial cancer is because researchers state that more than 70% of the cases that have reported are from this category. Under this, we are focusing on the high-grade serous carcinoma datasets. So these are the distribution of papers that we've used for our survey. We have surveyed around 100 papers ranging from years 2018 and 2021. So this is a basic diagram of the evolution of CNN right from the beginning of era, 1989 till 2020. So we've started from the first basic architecture of CNN. Researchers have concluded that the advantages of the basic CNN architecture are very high accuracy in image recognition problems and automatically detects the important features without any human supervision. And there is weight sharing advantage, whereas the disadvantage is that requirement of a large data set and its inability to encode the position and orientation of the object. Moving on to LXNet. LXNet allows The advantage of LXNet is that it allows multi-GPU training by putting half of the model's neurons on one GPU and the other half on the other GPU. The disadvantage is that since the model isn't very deep, it struggles to scan for all the features, thus producing poor performing models. Moving on to the ResNet architecture. The advantage of the ResNet architecture is that with the large number of layers, it can be trained easily without increasing the training error percentage. Whereas the drawback of ResNet is that although ResNet has been proven powerful in many applications, one major drawback is that deeper networks usually requires weeks of training time, which eventually makes it unreasonable for real-time implementation. Moving on to the last model, which is UNIT. The advantages of UNIT is that it is a convolutional network that is specifically developed for biomedical image segmentations at the Computer Science Department of University of Freiburg. The UNIT model provides several advantages for segmentation tasks. First, the model allows for the use of global localization and content at the same time. And second, even with very few training datasets, it provides high performance for segmentation tasks. The only drawback that UNIT has faced so far is that since the UNIT architecture is deeper, the learning may slow down in the middle layers. This is the only risk that the UNIT models have been reported on. This is a summary that involves the various networks, that is CNN evolution networks, based on the ROI. Since ovarian cancer is still an under-researched area, we have focused on medical image segmentation models with different ROIs. So this is a summary of the different ROIs, which have gained more than 90% of the accuracy for the different variants. So in conclusion, we'd like to state that this survey summarizes the standard network CNN architectures. And from this study, we've understood that the UNIT is the most preferred and widely used for segmentation of medical images due to high performance measures. So this is the proposed flow of our preliminary model. The data set is obtained and annotated. Then the masks are generated for augmentation. The binary masks are generated for segmentation, and the training data set is augmented. And later the model is trained, the unit model is trained, and the results are evaluated. The data sets were obtained from SRM Medical College after all the ethical clearances were obtained. And initially we've started training the preliminary model with 92 datasets because the available datasets were limited only. And these datasets have all stages covered. Malignant HGSP cases of all stage 1, stage 2, and stage 3, stage 4 patients are covered here. These datasets were manually annotated by our radiologists for ground truths, which was then annotated during using Fiji for giving it as input for the unit model. These are very few of our sample subjective results of segmentation. And these are the results obtained. The work is still in progress. So we probably we are looking into collecting new data sets for increasing our data set count for further processing, ma'am. And also stage-based classification will be done post the malignancy ROIs are identified. These are a few of our references. Any questions, ma'am?
Yeah, you are talking about the binary mask.
Yes, ma'am.
Have you obtained the binary mask as a ground truth, because that is very much needed for the segmentation?
Yes, ma'am, we have, ma'am.
Have you obtained it? From where you have obtained it? From the radiologist, or you have created the binary mask?
From the radiologist. We are associated with Dr. Saravanan, who is a radiologist at Aryuparai Veeder. So with his help, we have proceeded with this work, ma'am.
The mask is also being obtained.
No. Masks we have done, ma'am.
How you have created this mask? What
Fiji,
you have
using
used?
Fiji. Referring to the manual annotations from the radiologist, we have inputted it. We have generated masks using Fiji, ma'am.
What is that PG?
FIJI. Fiji is an annotating tool, ma'am, for generating binary masks.
Okay.
So in that case, if you give that image, then the mask gets generated. Is that so?
No, ma'am. We'll have to manually mark the pixels and generate them as TIFF binary masks, ma'am. And we'll have to input both the original image and the annotated binary masks for the semantic segmentation.
After creating this binary masks, have you validated with the experts?
As I said, ma'am, this is just the preliminary work. The work is still ongoing. We'll definitely get an expert's advice for further processings, ma'am, once the work is complete.
So your inferences is this unit is suitable for this type of whatever this what image you have taken.
It is reliable. It is reliable for biomedical image segmentation of ROIs is our inference, ma'am.
Okay.
So how do you know that these are all the correct coordinates of the tumor, and without any experts without any experts confirmation, we will not be able to release this anywhere, right? So
ma'am, that's what, ma'am. For annotation, for marking the ROI manually, we've had the help of a radiologist. He has marked the tumor region ROI manually on the, for example, say we've taken 5 patients, and for each patient we have follow-up scans and so on. And for each follow-up, we have more than 100 images, no, ma'am. He has marked from which image, for example, say 56 to 101 it is visible, the tumor is visible, and from where to where he has marked the regions manually and given us, which we have input it to the annotation tool, ma'am.
Okay. But very good attempt, ma'am. Thank you.
You will be able to predict the stage, like initial stage or advanced stage of the disease also?
Yes. So what we have planned is, after the ROIs are segmented, we have focused only on the malignant ones. After this, we will be constructing it. We will be hybriding, producing a hybrid model which can be incorporated with this unit for classification of stages. We'll extract the features as CSV files, and we'll probably apply a machine learning model for stage-based classification, sir.
You are not going for any deep learning model for classification?
No, ma'am, because once we obtain the features, we are currently aiming to produce a non-invasive technique. If we for example, say I'm going to extract Harlick features from these segmented masks, I will have them as a set of numbers only, no, ma'am. So in that case, my thought process is that machine learning model will be suitable for numerical data
To extract the features. In what way, what features you are extracting?
Now we have performed segmentation and we have identified the ROI, right, ma'am? The ROIs will be cropped and sent as input for the feature extractor, and the features will be extracted as a set of numerical values over which data science will be performed, ma'am.
Whatever be the features, at last we will be end up with numbers only. I cannot say since my features are in numbers, I can go for a machine learning. That is not a valid point to say, no. Whatever the features may be, we finally end up with numbers only.
Ma'am, but once ROI segmentation is done, that will be our only
because you have done the ROI in using a deep learning technique. Why
yes,
then? Why you are switching to a machine learning technique for doing
ma'am,
the
we haven't
classification?
explored it. I mean, for the classification part, we haven't started the exploration, ma'am. I'll probably look into the deep learning options as well, ma'am. It was just my thought process. I was thinking only ML model would be suitable. When I'll do the literature survey, probably I'll get an idea if TL model will work for it, ma'am.
Okay. How many images have you used for this unit?
As I said, right now our data set is limited. We have 92 data set with us. We have done augmentation. We have performed 5 augmentation steps for each data set, and we have processed the training with 460, ma'am.
Can you list out the augmentation techniques you have used?
Yes, ma'am. We have transpose, upsampling, downsampling, and I think orientation and Gaussian blur, ma'am.
Okay. Sir, any other questions?
Yeah, no problem. Yeah. No, madam. Yeah.
Okay, then. Thank you.
Thank you, ma'am. Thank you so much. We'll look into your inputs, ma'am. Thank you.
Ma'am, Manali, ma'am.
Ma'am.
Ma'am, actually paper ready 62 is ready, but I think paper ready 78 is having one a problem. She's having a problem in network. She wants to present it now. Is that fine?
Okay. Can we move on to the paper ID 78? Mohammed Safiq. Mohammed Safiq.
Author of paper ID 62, can you please respond? Shall we let the other one?
Okay, ma'am. We can wait, ma'am.
Okay.
Thank you. Thank you.
Thank you.
Yes, paper ID 78, an improved ensemble extreme learning machine classifier for detecting diabetic retinopathy in fundus image. The author is V. Desika Vinayagan.
Good evening, ma'am. Can I share the screen, ma'am?
Yes, yes.
So, okay, ma'am. Thank you. Yes, ma'am. My name is Desika Vinayagan, and the project title is an improved ensemble extreme learning machines classifiers for the detections diabetic retinopathies in fundus images. And the content are the objectives, introductions, literature survey, proposed methodology, result and discussions, conclusions and references. The main objectives is the papers is to detect the automatic diabetic retinopathy detection systems using fundus images, and the proposed automatic DR, that is diabetic retinopathies, screening the models and save the time of the ophthalmics in the disease diagnosis. So in these approaches, the segmentations is conducted using an improved Watt-Shield algorithms and gray level co-occurrence matrix, and it is used for the feature extractions. And the EELM, that is improved assembled extreme learning machines, and it is used for the classifications, and its weights are turned using the crystals structures algorithms, and it which optimize the loss functions of the EELM classifiers. And the experiments are conducted using two data sets, namely drive and measures, by comparing the proposed approaches against different stages such as support vectors machines, VGG19 assembles classifiers. When compared to the existing analysis, our proposed analysis has the sensitive specificities and accuracy scores 97, and the specificities is of 97.3 and the accuracies is 98%. And the introduction is the retina means it is an anterior thin layers that is presented at the back of the eyeball, which is the main purpose of the retinas. And is
hello.
Hello, ma'am.
Can you go ahead with the next
okay, ma'am.
Proposed
okay.
one. Proposed.
The proposed methods, we have 4 different phases, that is image pre-processing, image segmentations, feature extractions, and feature extractions can be done by using GLCM and crystals optimized EELM classifiers. And the first is the pre-processing stages. Initially the pre-processing stages, the input is from the drive, the input is taken from the 2 data sets, and the pre-processed image has been produced by using the adaptive histogram equalizations techniques. So, and in these steps, the background images is normalized and the illuminations is equalized during the pre-processing stages. And the next stage is the segmentation stages. During the segmentations is mainly applied in the optic disc regions of the fundus images, and segmentation images is mainly conducted using by using the algorithm improved Wattfield algorithms. And the reason for choosing these algorithms is that it is the capabilities to identify the brightness areas and also to solve the low color discriminations problems. And also in these ways the algorithms helps in improving the accuracies of the classifier even more. Here the mainly the threshold values is selected that it should exceed the maximum intensity values of the fundus images. Then the region in the optic disc is identified by segmenting the regions along with around the final optic disc candidates. So the boundaries of the optic disc can be identified through the threshold regions. And then the third phases is the feature extractions phases. This can be done by using GLCM. Here the pre-processed images is given as an input to the GLCM for retinal remover and blood vessels segmentations. And these algorithms is mainly applied to the pre-processed images, and the surface heterogeneous surfaces has been identified by using this GLCM. And the textures in terms, it is used in GLCM to identify the gray level variations and tones presented in the input of the fundus images. Next, these structures is formalized to initially a grayscale matrix of the images is transformed to the integer matrix by dividing the continuous pixels ranges to M bins. So the bins are equally valued and are mapped into single gray levels. So the pixels are adjacent and can represented using 4 different angles, that is 0 degree, 45 angle, and 90 and 135. So the genetic elements of this matrix are represented by G of X comma Y. And during the classification stages, it is trained with the appropriate input images from the 2 data sets, and it is obtained from the optical outcome of the for the input. So the reason is the reason for the ELM architectures is selected in this work to improve the generalizations performance and also the faster learning speed, minimum training errors, and easier implementations, and the importance of user input data, and also offers significant accuracies. The weighted assigned to each members of the assembles is optimized using the crystals algorithms, and the efficiencies of these algorithms is evaluated using the loss functions. So our proposed method has to
See here,
classify.
one
Yes,
thing,
ma'am.
why do you want to read all this information?
No. Yes, ma'am.
You are reading this information, whatever is in the slide.
No, ma'am.
Can you do your presentation because you have prepared the slide?
Yes, ma'am.
Okay,
Yes, ma'am.
so what is that you have done? You can keep going. No, why do you want to read whatever is there for us?
No, ma'am. Yes, ma'am. I have to explain, ma'am. So in the classification stages, we can classify the diabetic retinal images into 3 types. One is a homospace and microangiosperms, and another one is the exudates. In the first, we have to explain about the microangiosperm. This is the initial stage of the diabetic retinopathy, and during the microangiosperms, here we can in the retinal images there is a red spot started, and the size of this red spot is fewer than that is fewer than 125. So if the size of the red spot is fewer than 125, then the symptoms is based on microangiosperms. So then the lessons have during these symptoms we can have it can mainly occurs because these diseases can mainly occurs due to the weakness of the vessels. So if the retinal images, retinal vessels is weaker, then the red spot will appears in this retina. These processes are done for these symptoms. We can classify that the retina is affected by microangiosperms. Then during the second classifications, how to identify the second classifications is that if there is any irregular margins, and also the size is that and also the size is larger than, that is larger than 125, that is the weighted values of the size is larger than 125, then these symptoms is occurs due to homospaces. And then last is that exudates. Exudates means we can classify the exudates into 2 types. So one is hard exudates and another one is soft exudates. The hard exudates means it can occurs due to if there is any leakage of the plasmas, and also a bright yellow spot can appears in the retinas. And in the soft exudates, there is some swellings can occurs in the nerves fibers, and there can usually represented as a visual spots. So these are the 3 classifications of the diabetic retinopathies. So here we can give some average values. So based on these values, we can have to classify the diabetic retinopathies. So this is the classifications result of diabetic retinopathy by using ROC curve. So there is an perform analysis of the proposed methods. So here we can have to find the accuracy, specificities, and the sensitivities of the 3 classifications. Then for the final conclusions, first we can have to use the pre-process methods, and then we can have the segmentations process has been done by using these algorithms. And feature extractions, in the feature extractions has been done by using GLCM techniques, and also the improved watershed algorithms can be used for classifications. Then the third stage is the final stage is the classification. The classifications has been done by using the crystals it can optimize, and also using the ELM architectures. By using these classifications, we can have to find out the accurate sensitivity, specificities, and accuracies of the classifications images. That is the 3 classification stages. So finally, we can have by using these classifications, the computations time of the proposed algorithms has taking the time seconds is 15.36 seconds, which is lower than the existing techniques. So these are the references, ma'am. Hello, ma'am.
Yeah.
Hello.
Hello.
Yes, ma'am. Yes, ma'am. We are listening and we are here.
How many images you have taken?
Yes, ma'am. I am in the data sets of first drive data sets. Have to taken 1,200 eyes of images has been taken, and then we can classify the is it in the training data sets.
So you have given the performance analysis only for the classification. You have done a
Yes.
segmentation also, no? Have you?
Yes, ma'am.
Have you done any performance analysis for your segmentation part?
No, ma'am. Only perform the analysis for the classifications process.
Not for the segmentation.
No, no, ma'am.
So you told that you have extracted the features, DLCM features. What is the feature size, feature vector size?
The size is
How many features have been extracted? What is the feature size?
the
What is the
feature
feature
size.
vector size? Feature vector size.
How many features have you extracted? That's the question.
Yes, ma'am.
Have you done that? Or only
Only for the classifications
classification?
process. Yes,
Okay.
ma'am.
Even for the classification, what are the different features with which you have taken the consideration and classified?
We have to taken the 80 part of the images has been taken in the training data sets, and the 20% is used for testing, ma'am.
That is all right. You are telling that no, you are using GLCM features. What is
Yes.
the size of the feature vector? I'm asking. And you are talking about your classifier, ELEM classifier.
Yes, ma'am.
What is the advantage of having that one? Is why you have chosen that one?
Because it can have the because it is the it can find out how frequently the combinations of the pixels presented in the images, ma'am.
Have you done the segmentation actually?
Yes, ma'am.
Is segmentation part of your work? Have you done it? Because you haven't validated it with all these parameters, accuracy, specificity, and sensitivity. So have you done it?
Yes, ma'am.
Then why you did not validate?
Because your accuracy of your classifiers purely depends upon the segmentation that you have done.
Yes, ma'am. The result is from the segmented
Yes,
images.
then you need to validate your segmentation algorithm, no? What segmentation algorithm you have used to do this one?
Here we can use in the segmentation process, we can use the water shield algorithms has been used, ma'am, to segment the images.
Okay, then you have to validate, no? You should have some ground truth of the segmented part. You have to compare
Yes,
the ground truth and whatever you
yes,
got
ma'am.
it, you have to
Based on the
validate.
based on the threshold values, ma'am.
Okay.
Because compared to that, if it reaches the maximum intensity values, based on that we can should not exceed the maximum intensity values, ma'am.
Okay. Shama ma'am.
Yes, ma'am. Let us proceed, ma'am. Next.
Okay, thank you.
Okay, ma'am. Thank you.
Thank you, ma'am. I would like to call upon the paper ID 62.
Yes, ma'am. We are being.
Detection and classification of groundnut leaf disease using convolution neural network. The authors are Dr. S. Makeshwaran, Indumadi N, Dr. S. Dhanalakshmi, Nandita S, Muhammad Safiq, and Ritika.
Ma'am, is my screen visible, ma'am?
Yeah.
And our research topic is on based on detection and the classification of groundnut leaf disease using convolution neural network. And the main
Where are you
objective of
from?
this
Which college are you from?
from Congo Engineering College, ma'am.
Okay.
And the main abstract of our research paper is on groundnut leaf disease. And since groundnut is a major oil seed crop and food crop, the disease occurs on the leaves of the groundnut, is greatly impacting on the quality and the production of the groundnut, and the yield is also reduced. So due to the reduction in the yield, the oil manufacturing process is also reduced, and the gain is reduced, and the loss is increased. So we have planned to make a model with the help of an artificial intelligence and DCNN model to identify the leaf disease such as leaf spot, rust, groundnut bug necrosis, root rot, and whip blotch. And in this model, we have 85% of the disease occurs on the plant leaf. So we have majorly focused on the leaf parts of the groundnut plant. And this research mainly fascinated on the identification of single and mixed diseases on each of the every groundnut leaf. And the identification of these disease by the farmers through the bad eyes is not possible. And even if they identify, the accuracy of the identification of disease is not that much correct. So if the misidentification leads, then the pesticides or the fertilizers used by them will be wrong, and the total yield will be damaged. So we have taken this research paper, and here we have used a k-fold cross validation technique and along with the DCNN model. This research is highly developed as an hybrid rather than modifying the existing model. These are the diseases which have been selected. Early leaf spot caused by Cercospora arachidicola, late leaf spot caused by Cercospora personatum, root rot caused by Macrophomia fasciolina, and groundnut bud necrosis caused by groundnut bud necrosis virus, and wet blotch caused by Phoma arachidicola. And our proposed methodology is on DCNN model for the identification and the classification of leaf disease. In DCN, before going to DCN model, we have done pre-processing, future extraction, data processing, and the tool selection and evaluation technique. Here for image processing, we have selected images. We have taken two types of images, first primary and secondary data. These data are then collected of 3,600 images and distributed into 5 classes. And also data acquisition is also used to get and clear digital images with uniform illumination and lighting. And we collected these images through smartphone and digital camera and stored in them the PNG format in our hard disk. And after these processes have been done, we have moved on our techniques. In our DCN model, we have 5 layers. And using the 5 layers along with the filters, we have proposed our DCN model. And this is the process model of our DCRM. First, we have taken the problem-centered initialization that leads to the problem's identification. From the identification, we are interference of the problem. Through that, we have obtained our objective. And through the theory of the objective, we have developed and designed our model. And to design, we have need an affirmation. We have done that. And the inspection of the demonstration model have leads to the evaluation, and practical experience made our conveyance. And this is the general block diagram. First, we have done the acquisition of the images using cameras. After these images were let into RCB image datasets. And after that, we have done the image processing process.
See, did you acquire the images using the camera and did it, or
we acquired images through smartphones and digital cameras.
Okay, so so after collecting the informations, how you segregated?
Ma'am, we get and help with our agriculture farmers and our co-workers, ma'am. So through their knowledge, we have for us we have segregated, ma'am. After designing these model, we have trained and we have cross-checked with what we have segregated as our result, ma'am.
So what is the format you have used here? What sort of image you will be getting, and what is the format of it?
We have used PNG format, ma'am.
Pardon?
PNG format.
PNG. Okay. So what is that image you captured?
The leaf diseases, ma'am.
Pardon?
Leaf diseases of groundnuts.
Oh, leaf. Only the leaf you
Yes,
took.
ma'am. Yes, ma'am. Major disease in the groundnut is occurred on the leaves, ma'am. So we have concentrated only on the leaf parts.
Okay. So at what angle did you took the images?
90 to 180 degrees.
Okay. No, so all the images in the same range of in the same degree you captured
ma'am.
the images, huh? You
Yes, ma'am.
captured using camera.
Yes, ma'am.
So what is the data you collected? Is it in the same region or different region you used for collecting the data?
Ma'am, we have moved over 1 or 2 agricultural lands to get different diseased leaf, ma'am.
No.
Not on a particular.
The same village or different districts you have collected data? Because Swaminathan Foundation has a huge database, agricultural database.
In the same district, but we have moved on different villages.
Because you are from Coimbatore, you could have consulted them.
Yes, sir. We are in Erode district, sir. So in Erode district, we have visited many nearby villages around our college.
Okay, so what is the camera that is some what to say what is that? That in some for getting the accurate camera images. So what sort of a camera you used?
Ma'am, Canon, ma'am.
Huh?
Canon cameras.
Canon camera.
Yes, ma'am.
So will it give you the accurate result?
Ma'am, for that
Canon
we have
camera, will it provide
we
you
have
with
done pre-image processing techniques to make the images more clarity with uniform illumination of light.
pardon, I didn't
So
get it.
is the encoding technique very much dependent on the camera, or have you used something very much generic, ma?
Ma'am, depends on the camera we have used, ma'am.
So can you make it much more generic, because it is dependent purely on this camera only, right? And that's, I think that is the question Chamundeshwari ma'am is trying to ask. So the encoding technique should not be device dependent, right? So it should be much more generic, so that any camera, in whichever camera the image is being captured, it should be made use of. The system should be working.
Okay, ma'am. We will look after to it.
And did you not get any data set that is there available, or did you approach the agricultural department in Coimbatore? Agricultural University that is there in the Coimbatore, you could have approached there, right? Did you go there and check with them?
No,
and one
we
more
only
thing is
faced with our agriculture researchers who have been with our colleges.
okay,
Pardon?
one more thing is that camera plays a role, and in what angle you are going to take that image, that is also very, very important. And it district wise also there will be difference from one place to the another, also it differs. So you have to focus in one region alone. Okay, in one region alone, if you concentrate, then the results may be good. It may be helpful for the farmers. And did you compare the images with the existing image? What is the quality of the image you acquired and the existing image? Suppose some other similar to this you would have heard, right? In the data, some data set must be available.
Ma'am, we have verified it with online images, ma'am.
You verified with the online image?
Yes, ma'am. The pixel of online image is less lower than ours. So we have gone through it.
So finally, what is the data set you use for this? From the online you took it or you took from your camera?
We took from our cameraman, but the quality is verified with different images. We thought of our camera is good.
So how many images you used for this particular study?
3,600 images we have used, ma'am. For training a data set, 2,880 images we used, ma'am. For testing, we have used 720 images.
You should have taken a benchmark data sets from some research foundation, right?
Okay, proceed.
And after the image processing, we have gone through our feature extraction process. Through that, we have trained our DCNN model, and after that, we have implemented it, and it results in the classification of leaf spot, rest, root rot, web blotch, and bud necrosis. The architecture of DCNN model have two sections, namely classification and future learning section. It starts from the input and ends in an output layer. We started feeding the images through the input layer, and the output layer will be consisting of many hidden layers with different layers. The output layer is named on the approach name, which is the disease name of the groundnut leaf. And the processed augmentation output for the forthcoming layers are prepared, and it is replicated. The output layer shows the predictant task for the neurons for this model. And the layers we have used is convolution layer, pooling layer, ReLU layer, fully collected layer, and loss layer. In the convolution layer, we have used the impartial community, which leads to the layer to be small. And
Go ahead with the next layer. You are going to explain about all the layers here.
Yes, ma'am.
Okay.
Then this is our architecture of our model, proposed model, ma'am. Here we are giving our input image through the future extraction. We have listed our future through the traditional pattern recognition, and after that we have obtained the low-level feature.
So totally, how many features you have used in your study here?
Ma'am, couldn't get, ma'am.
No, how many features you are going to use here in the study after feature extraction process for
ma'am, we have used of 5, ma'am.
How many features totally? From the input image, how many feature, and after process feature extraction, so how many features you got it?
We have after feature extraction, we have 5 feature list we have obtained.
5.
Yes, ma'am.
Okay.
What are the features?
Ma'am, leaf spot, root rot, and bud necrosis, rust, and web blotch, ma'am.
All these are the disease name, no?
Ma'am, we have been listed, feature list have been named as like this. We have given us disease name.
What technique you have used to do the feature extraction?
K-fold cross-validation technique.
K-fold cross-validation technique. You are using a deep learning model, no?
Yes, ma'am.
Are you extracting features and giving the features to the deep learning model? Or the deep learning model itself is extracting the features?
Ma'am, model itself is extracting, ma'am. After image processing, we have only feeding that, ma'am.
After image processing, you are feeding only the processed image to the model. The model, your model will be extracting the features.
Yes, ma'am.
Is it so, or you are doing any using any image processing algorithm to extract the features?
No, ma'am, model itself is extracting, ma'am.
Then how come you know what are the features that have been extracted? You are listing some names.
Ma'am, after the feature list have been obtained, we will be.
What is the feature list? What do you mean by feature list here? What is this process? What is this 2 boxes will do? What the 2 boxes will do? This is where your features have been extracted by your deep learning model. What is this 2 boxes?
That will extract.
You have made this one, no? Low level feature, mid level feature, high level feature. That
Yes,
all be done by the model itself, no?
Yes,
what model you are using? DCNN model.
DCNN, yes, ma'am.
Yes. And what is these two blue boxes? What it will do? What do you mean by feature list then? Are you doing any special thing to extract the features and you are feeding the features to the model?
Ma'am, we will be extracting the future, ma'am, but
What
not
features
feeding.
you are extracting? How will you extract the features and give it to your model? Then what is the purpose of the model then? You have made all these things, no? Low level feature, mid level, high level features, and you have given it for the neural network model itself. The thing is, this model will go
Using the
extract the features.
mechanism of filtering values, we will be matching the exact.
Then what is the purpose of these two boxes? I don't understand the flow. What do you mean by feature extraction process here? Is this the part of your model or what?
A part of a model, ma'am.
So this will be done by your model.
To correct the level of the images, we have been doing this, ma'am.
What?
To correct the level of the images, we have been doing this, ma'am.
What to correct?
Level of images.
What level of images? What do you mean by that? Okay, proceed.
And the parameters we have used are data set color, number of epochs, augmentation, and optimizer. And
what is the result analysis you were able to produce? Where is that information? Go ahead with that.
Ma'am, we have been cross-verified with the training and the testing data set. Ma'am, the graph we have obtained is better in testing data set. Ma'am, we have obtained accuracy of 97.5% in the testing, ma'am.
Okay, you have any table or anything for presentation about the result here?
Ma'am, in another slide, ma'am, I will show that. Ma'am, this is the table we have obtained, ma'am. The dropout we have used, the accuracy we have gotten, ma'am.
Okay.
For the particular approach, what the dropout we have used and accuracy we have obtained, ma'am. And this is for the training versus validation accuracy, ma'am. We have got the validation of up to 96.5%. Ma'am.
Have you applied SMOT technique?
Sir, couldn't get this.
Have you applied SMOT technique?
No,
the data set is not balanced one.
Sir, we have used this, that for only classes to get a balanced data set.
Suppose if you have not all the parameters have values, in that case you may have zeros, right?
Sir, couldn't get, sir.
So if the data set has filled with a lot of zeros, sparse matrix type,
okay, sir.
Then how do you process your data set and then proceed? Have you applied any SMOT technique there?
No, sir. I don't have that idea of knowledge, sir.
Sorry. Any other question, madam?
If no questions, we will proceed to the next paper, sir.
Yeah, fine.
Yes, thank you, ma'am.
Thank you, ma'am. I will look into the queries which we have been given. Thank you for your suggestions.
You have not extracted any features. You are just giving it to the CNN, DCNN only. You have described a diagram such that you have divided the CNN like this: feature extraction and classifier. You are just giving the image to the CNN. Okay. You only have drawn this diagram. Both this classification and feature extraction will be taken care by the CNN itself. Okay, then.
Okay, I will look into it. Thank you.
It's the next paper, the paper ID 67, COVID proc. The authors are Dr. K. Jayashri, Akhilesh KR, Aristotle D, and S. Ashok Balaji. Who is going to present? Authors of paper ID 67, please respond.
Hello.
Yeah. You can share your screen. Aristotle. We are not able to hear you. Can you able to hear me, Aristotle? Can you share your screen?
Just one second. Is it still visible now?
No. You have not shared it.
One second.
If you are facing any problem, can we move on to the next paper? Can you present, class?
Hello. Sorry.
Hello? Are you facing any network issues?
Ma'am, am I audible? No?
Yes, you are audible. Your screen is
Yeah,
not
ma'am,
shared yet.
Yeah, like actually, yes, sharing. But I don't know what is the problem. Just give me. All right, we present the last one.
Okay, can I ask the other person to present now?
Sure, sure, ma'am. Sure.
Thank you. Yes, I would like to call the authors of paper ID 71, Accident Detection System using Deep Learning. The authors are Amala Ruby Florence and J. Krubasri. Authors of paper ID 71, please respond. Amala.
Ma'am, am I audible?
Yeah.
Yes, ma'am. Let me share my screen. Is my screen visible, ma'am?
Yes.
So hello, everyone. So the topic which I'm going to present today is the accident detection system using the deep learning algorithms. So
where are you from? Which college?
Sona College, ma'am. Okay. Yeah. So the problem statement is that in India, around 1.5 lakh people die every day due to the road accidents. So the major factors that are leading to the road accidents are not timely available of help, because of which the number of deaths increases, and also the rescue agencies and the vehicles to respond to accidents are also delayed in rescuing. And by developing an automatic accident detection system, this can be used in a real-time monitoring surveillance system. So there are many proposed systems earlier, which includes the traffic flow pattern analyzing and using vehicle activities and by modeling of the vehicle interactions. So in the case of traffic flow modeling, where the when there is a dense of traffic is happen, and also based on the collision or the collision data, like we'll be getting if the accident has occurred in a particular area or not. So whereas in the traditional detection approaches, the quality of data determines how the traffic flows. So the data, the quality of the data should also be a proper one, and as well as it should be it should be open to all sets of data. It should have been tested or trained with all different weather conditions and as well as different conditions. So the existing system suffers from the trade-off between the computational overhead and detection accuracy. So this system aims to detect various classes of vehicle. So this forms the phase one of detecting the vehicles. Further, it will be for the accident detection and also classifying the severity of the accidents. So the motivation of this is to increase the efficiency of the response rescue agencies by increasing the efficiency of the accident detection system. So the ability to detect and track vehicle this can be used in the real-time monitoring, and also by having the improved efficiency, this will greatly reduce the number of accidents by meeting the need in time. So for the extension of for the classification based on the severity, this can be extended on using the 3D CNN the classified object based on by including the volume of the data as well as, so which will be providing the severity of the accident. So to further to alert the hospital based on the severity and also taking the location of the CCTV that is present, this can be also provided as an additional information. So the literature survey, do I continue, ma'am, or do I need to skip the literature survey?
You can skip the literature survey.
Okay. So in the module consists of the collection, processing, and the feature mining and the detection system. So in the data of collection, the data set that was used from the online sources of the video from the YouTube that were taken around 300 videos, and also the CADP data set, which has the accident, but the data set was taken from a wide range of different locations, but in order to meet the accident that happened in India, so I've taken gone the general search of having the accidents in India, and from the videos obtained from the YouTube, like the videos for each videos, it was converted into frame, and by analyzing like for the frames where the accident has happened, and collecting those frames and training the model for the classifying the classes of objects. So the object classes which were made on as a car, a bus, and motorcycle and truck. So once the classes of the vehicles were obtained, I mean these were obtained for various lightning weather conditions in the day, night, snow, rain, and etc. So once the image is collected, the images are annotated based on categories using the manual online tool that is the Make Sense. And in order to provide, in order to use the YOLO V5 algorithm, we require the YOLO V5 format. So for which in order to transform the frames into, provide the bounding box labels. So these were manually bounded to get the in the form of the YOLO V5 dataset in the format. So once the labeling is done and annotated, so the training and the testing dataset was split into 80:20 ratio, and dataset YML, which consists of the classes of the vehicles which to classify. And once we create the and separate by splitting the sets of training and validation, we then use the custom the specific YOLO V5 framework to get the best and the last weights. So once obtaining the weights, we compute for the specific for our data set, we alter the CFG and also the filters that was used and were altered, and with the custom YOLO V5 data, with the custom weights, our data set was trained, and we obtained the detection accuracy. So the methodology used in this is the images directly that is collected from the webcam. For now, for the training which we were using was the video that were directly available from the internet sources. So once this can be extended for using the real time, where the data will be of different extensions or the dimensions. So once the data is collected, the YOLO V5 algorithm which detects the localization of the object, and for classification and obtaining the severity, 3D CNN will be used. And once we process and through the web API, like we'll be able to send the communication to nearest control rooms. So this is the architecture of the YOLO V5. So in YOLO V5, we have the bottleneck, which uses the bottleneck CSP, and a spatial pyramid pooling, and the pooling layer which was developed for the original data, I mean, for training the YOLO v5 darknet frameworks dataset. For the custom dataset, like we altered the layers, and with the independent once the pooling and the filtering is done, further, like we will be producing the result of the object localization based on the class labels in which the image is present. So the proposed system is that from the real-time CCTV, we convert the videos into frames, for which we obtain the localization of the object. And once the localization of the object is obtained, this was done in the first phase of obtaining the classes of the objects. So which can be further for the analyzing of the accident detect by classifying the frames as if the accident has happened or not, and also on additionally, like to obtain the severity based on the damage that has happened to an object. So once this will be done using the 3D CNN, and further on for classifying it as a severity and to alert. So the implementation details, which includes we collected the data from the YouTube videos and the CDP datasets.
You're using a video, right?
Yes, ma'am.
So all the video images are used, or how you are doing it here?
Yes, for the case, if we take
go
the
to
video,
the previous one in the proposed slide. Okay.
Yes, ma'am. Yes, ma'am.
Yeah.
The video will have, if we take any video from the internet source, it will be around like 5 minutes, or even for that much of frames, there will be around more than 10,000 of frames, which won't be necessary information for us in order to find if the accident has happened or not. So in order to do that, like a specific frame where the accident has occurred.
Now, how will you find the specific frame here?
It's only for the training, it was done manually, ma'am.
Okay, so manually you will be taking it, and then for YOLO v5 detection, what is the difference here? The same input is coming for the video stream as well as for the YOLO v5 detection, no?
Yes, ma'am. The first phase is the the video, and the second, which is the frame which was taken from the videos, ma'am. Which is not actually a video stream; it was the frames of the video stream. For which,
but then I didn't get it. What is that?
No, for the frames we perform the YOLO v5 detections. So from the video we get the frames. For the frames we perform the YOLO v5 detection.
Okay, okay. So here for this detection, okay, you are applying that particular image and getting it. Okay. So what will be the format for both of the result, whatever you are going to get?
Result will be of, for the first phase, we are obtaining the classes of the vehicles. So it will be classifying if it is what is the type of the vehicle. It will be kind of a bus, car, or like the classes of vehicles will be identified in the first phase.
No, what I mean is that you are connecting the TV to the video stream and as well as to the detection you are applying, but the output you are connecting to the single one. How it will be the same? You will is it not that you will get the different one, or manually you're taking? I didn't understand that concept.
Okay, this is on once for the validation after the training. Once for the validation, when real-time video is provided for the video, like the frame for the each frames, the localization of object will be done, which will be the output in the. Will be the output, ma'am. For each frame, we'll be localizing the objects.
Okay, that is followed from the second one.
From this one or.
Yeah, from the video stream, you're taking a frame and then you're doing, okay, what about this deduction techniques? What is the output?
Output of the particular after the localization of objects, ma'am. Once the localization of object is done, this is considered as a low level of data. So for which the same it will be used for classifying the accident as well as non-accident images. So this will be considered as a low level feature of the data, and for high level of which will be including the.
No, there should be some difference, no, from the manual and manually you're taking and then applying this deduction. Does it? No, it doesn't make sense. Like that, the connection is not very clear. Okay, change it. Okay, not clear.
Okay, ma'am.
Okay, go ahead with the next.
Okay, ma'am. So this was the implementation was done like from the videos just collected, we converted it into the frames using the OpenCV, and we for manually for manually training it, we annotate the each frames with the classification of the vehicles. So once we annotate it, we get in the format of the YOLO V5, which is suitable for training the YOLO V5 model. So once we split the data as a training and the validation, the YOLO V5 weight is applied to it, and we get the custom weights for training our custom data set. So once we get the custom data set and we prepare the suitable filters and layers by altering it, like we get the custom CFG, and for the custom CFG and our custom weights, our data set will be trained, and it will be evaluated for the weights that we obtain, ma'am. The best weights will be suited and will be taken, and to validate, we'll be using the weights.
And after training, what is the difference between train and validation here?
Training is something which we provide, saying this is this object is which is a car or a bus. Validation will be only the image for which the model needs to build a bounding box, saying providing the localization of an object, ma'am.
And then training will also give the weight, and validation will also
No,
give
ma'am.
you the weight.
No, ma'am. Only the training will have the YOLO V5 weight, for which we'll be validating with the custom weight that we got from the validated one. From the trained one data, ma'am. The custom weight will be obtained from the trained data. So which weights will be suitable for our custom data set will be this weight will be used.
Because in the same slide, I'm looking this validation and validation result.
It's only
so
for
what is that?
splitting.
What is that you're conveying here, and what is this meant by this validation result?
Okay,
it is not very clear.
This part only says about we need the YOLO V5 format.
And it is not connecting to the previous slide, whatever you have given. So correct all these changes, okay?
Okay, ma'am.
Okay, go ahead with the next.
Okay, ma'am. So this was only for the first phase was done on only the vehicle object identification. So for the accident detection, like which the low level of data will be to classify the accident and non-accident data. And once we classify it, we'll have to.
Okay, you have any analysis table here?
For the YOLO V5, for the object detection, I have.
Okay, precision, and what is this IOU?
Intersection of or union, ma'am.
Okay.
When comparing, there is already a proposed model which uses YOLO V4, ma'am. But when comparing with the other existing model, the training which provided the result was much faster than the YOLO V4, but the accuracy was relatively comparable when compared to the earlier one. So this was inferred from the from the previous work which was done using the YOLO V4 now.
Okay.
So in this, like object detection was done in the first phase by using the YOLO V5 for the custom data set. So once this can be extended by increasing the amount.
Okay, fine. You can do that changes. Okay, when you are submitting the paper. Okay.
Okay, ma'am. Thank you, ma'am.
One second, ma'am. 1 second. I just want to get clarified with few things. What is the size of the video that you get it here? Or you got the CCTV footages, right? So from where did you get, first of all, and what is the size of the CCTV footage?
Yes, ma'am. It was from directly from the online searches of from the YouTube videos only, ma'am.
Okay, only from the YouTube videos you have taken.
The videos were taken from YouTube, and for comparison, like for including different data sets, I used the CADP data set as well, and some from the Kaggle as well, ma'am. But most of the data were taken only for training. I used only the YouTube data, ma'am.
YouTube data sets.
Yes,
but when you take it from the YouTube, and the encoding style for the YouTube and as well as the real CCTV footages are very much different, and it won't be giving you proper results. So that is what we have inferred from our experience. You can just check, because the real CCTV footage will be having a different encoding style, and the encoding style that is there available in the YouTube video will not
ma'am.
be one and the same, and it won't be giving the correct results when you go for the real CCTV footage then later.
Yes, ma'am.
Training everything with only the YouTube videos is not correct. So that is my part of observation. And what is the size of the video that you have taken?
It's 320 cross 240 pixels, ma'am.
No, how long? What is the duration? What is the duration? Maybe. My
For
question
training,
is
ma'am.
Yes.
For training,
Yes.
for 30 epochs, it took around 1+ hour, ma'am.
Lama, what is the duration of this YouTube video? What is the length
Okay,
or how long
it
the
varies,
YouTube?
ma'am. It varies, ma'am, because we need to collect from different locations. Because if we take around for a 5-minute video, there will be a huge number of frames, which we don't require many frames, which will be the again and again repeating data, which won't provide
So
any.
you are removing the redundant frames
Yes.
first of all,
Yes,
and
ma'am.
are you just slicing the video into multiple small chunks and then you are working on it, or are you working all together?
I chunk it, and then for each chunks I convert it to a frame, and then it's all the same process, ma'am. When we group all together and provide us to split it as a frame. Yes, ma'am.
Okay. What is the motivation behind this work? This is the final question, because you are finding out which frame is having accident part and which frame doesn't have accident. So you are classifying that, right? So
Yes,
what is the
ma'am.
motivation and who is going to be the user of this system?
The motivation of this is to improve the detection of level, ma'am. Earlier, if because each and every moment like matters. So earlier, if the system was able to obtain the classification and to alert if it takes around 4 minutes of time, so it will be, the motivation is to reduce the time of the detection, and it was the motivation, ma'am. And the users
who will be
the users would be it can be used in the real-time monitoring, ma'am, once the model is was suitable for the validation.
So you'll be using it in the traffic like a CCTV footage camera, you are going to incorporate this.
Yes, ma'am.
Okay, as a module, and when an accident occurs, then it should be alarming the
Yes,
respective first aid stuff you have
Yes,
to alarm. So that is the overall motive.
Yes, ma'am.
Okay.
Do we have any other questions, ma'am?
There may be multiple but GPS location from where this particular information is coming, all those stuffs. So that is a secondary part of the system. The primary part of the system is only the detection. Okay.
When the detection takes place only with the CCTV surveillance camera, ma'am, we get the location of the camera position where itself. So we don't require any additional requirement to get the location of the accident, ma'am.
Okay.
Ma'am, Valli ma'am.
Yes, ma'am.
We are running out of time.
Okay.
Can we move on to the next paper?
Yes, ma'am. Thank you.
If no more queries.
Thank you, ma'am.
Okay. I request the authors of the paper ID 67 to come and present. The title is COVID Proc. The authors are Dr. K. Jayashri, Akhilesh KR, Aristotle DS, and Ashok Balaji. Are you ready, authors?
Yes, ma'am. Just a minute.
Madam, the last paper, what was the ID, madam?
The last paper.
Just now one girl, she was
71,
presenting,
ma'am,
no?
71.
That is 71.
Yes, this paper ID is 67.
Okay, ma'am.
What? Are you ready or not, Akhilesh and Ashok Balaji?
Yes, ma'am. Just 1 second, ma'am. Like, just facing some network issue, ma'am. 1 second.
We are waiting for you for the last 20 minutes.
Ma'am, just a second, ma'am.
May I know what is the problem?
Ma'am, we are actually using MacBook Pro, ma'am. Like, we are trying to share the screen, ma'am, but it's showing grant permission access, ma'am. Though we have like granted every access, it is showing, ma'am. So we have now like switched on to our mobile phone. Now you're pressing. Just once again.
Yes, participants, please unmute and start speaking.
Ma'am? Hello?
Yes, we can hear you. Start speaking.
Ma'am, can you see the...
enlarge the screen.
Yes, sir.
Good afternoon to all present here, ma'am. And dear sir, and I'm very sorry for this extreme delay. And I'm Akhilesh KR from the Computer Science Department of the Rajashmi Engineering College, Tambalam. And I'm here accompanied by my friends Aristotle D and Ashok Balaji S. So we are here to present our improved solution of an existing solution, which became quite vital in these COVID times. As you all know, still in these COVID times, many people aren't wearing masks nor maintaining any social distancing. We have come up with a product solution which improves the existing one. So like many people don't know that even in the Chennai Metro also has extra feature in their security camera, which that they have which contains face mask detection. So, but just camera tracking down the face mask doesn't mean anything to like people. So we have come up with a model, COVID Proc, which is a combination of 3 ML models, a face detection model, color detection, and a crowd counting. So mask detection is basically used by the mobile video net architecture, and the data set is public data set as we got from the public data set in GitHub. So the next one is crowd counting.
Ma'am, can you hear me?
Yes, yes.
Yes, ma'am. In crowd counting, we are using CNN, ma'am, with VGC 16 architecture. We are using the
What is meant by cloud counting first?
Ma'am, we are detecting how many people are there in a given picture.
Okay. How this is connected with the mask detection?
Ma'am, we are simulating all the 3 ideas to one so that we can process it and use a speaker to send a message to the crowd that it is heavily crowded, please wear mask and maintain social distancing, like that.
Okay.
Yes, ma'am. Now we are using cloud counting with BGC 16 architecture, ma'am. Here, with an we use CNN with an advantages are that we can generate low resolution density maps. It is highly usable in day-to-day cameras, ma'am, because the pixels are in very low resolutions. which can be used to contain spatial distribution of the crowd, ma'am, which improves the accuracy of the predicted results. Then now it's color detection, ma'am. Aristotle will continue.
So in color detection, we are basically why we are using this is to identify the person. If he is not wearing the mask, we are going to identify what color shirt is wearing, and if we inform what color shirt is wearing to microphone, he'll get a psychological imbalance. And he
Okay,
will
how did you got all this data set, first of all?
data sets. It's in GitHub, open data sets,
Okay,
open source.
from there you took those data sets and you worked. Okay, fine.
Yes, ma'am. So we have completely implemented color detection using Python OpenCV library, ma'am. And we are capturing the video through web, surveillance camera or any web camera which is available, and we are reading the video image and we are converting it to image frames, ma'am. And then in image frames, we are converting the BGR value to HSV value, and then we are creating a morphological transform and we are
See,
dilating.
students, show all those things. Okay, what you have done. Just go ahead.
So
okay. Next. So you have taken this application. Okay,
this
some
is
benefits are
application,
there.
ma'am.
Fine,
I
go
am.
ahead. Show your proposed work.
Yeah.
Your diagram is there. Anything?
This was actually supposed to be a video, ma'am.
You
We
need
actually created a
diagram?
video, ma'am. Yeah, ma'am. We created a video for our project, ma'am. Like we made this video.
Okay.
But, like in this mobile, we are not unable to play anything, ma'am.
Actually, we are not interested in that video, but we want the architecture diagram. And how did you went? This is a research forum,
ma'am.
okay, where we are interested in the how you present it as a research component. Okay, so that is the interest here. And this is not the product. We are not. It's not related to the product we are looking here. Do you have any presentation with you?
No, ma'am,
Architecture
actually,
diagram and how the
in that
flow
video,
went
we
on,
actually
and
we created
how
architecture
the
diagram, ma'am.
data set, what is the results you obtained. We want all those information.
Yeah, basically the data sets for the face
No,
mask
show
detection.
show that in the presentation. Okay, we don't want you to talk. Just first show that. What is that you have in your data in your presentation?
We had a video which like graphically represent all our architectures and like stuff. But
Yeah, show that.
it isn't playing in mobile phone, ma'am. Like
Ma'am,
Ma'am,
actually, Manali ma'am and Chamu ma'am, we are running out of time, ma'am.
Yes,
Actually,
no, they are not showing the presentation. They have some slides. Okay, they have shown only the conclusion references and the first 2, 3, 4 slides they are having, but not with the architecture or what is the some algorithm they are telling they applied for the data set. What sort of a data set it is? Nothing is they are not projecting.
Ma'am, we can ask them to incorporate in the paper and let them
Ma'am,
modify it and submit, ma'am.
Yes,
we have
then
included
no,
it in
they,
the
okay.
research paper, ma'am, but we have not included it in presentation, ma'am.
Okay, we will verify it, and it might not be the paper, the manuscript which you have submitted may not be the final one. We will verify, let the session chair decide on whether it is going to be the final one or not. Okay.
Okay, ma'am. Okay.
Okay.
thank you so much, ma'am.
Okay, ma'am.
Thank you. Thank
Yeah.
you. Sir,
We can wind up the session.
Okay,
yes, sir. Yes, sir.
Thank you, sir.
Okay.
Thank you,
Ah.
sir.
Thank you.
Shamu
Thank you,
ma'am and thank you, Valli Devi.
Prasad sir, thank you. Chamu ma'am, thank you, ma'am.
Thank you, madam. Thank you, madam.
Okay.
Thank you, ma'am.
Thank you, madam.
for the
Thank you.
opportunity.
Manali ma'am and Valli Devi ma'am, thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you.